Hello everyone and welcome to yet another recreational programming session with Ahu and Mr. Azozin. So, lately we've been developing this really weird thing, right? So I was playing with a raycasting algorithm in web, right? So essentially raycasting algorithm is basically like a 3D from 90s and 80s. Wolfenstein 3D was implemented using this kind of technique. It's a very simple technique and it doesn't even require any OpenGL or anything like that. This entire thing is actually using 2D canvas, right? It is using 2D canvas. It was kind of fun, it was kind of interesting, but then I thought, can we make a game out of that, right? So I kind of really want to make a game out of that, especially because I have a very old laptop, so not that many games, like I can't really play that many games in here. So, and yeah, so I can just like implement a game that I would personally play in, right? So to just entertain myself. And what kind of game I would like to play? I really like to play roguelike games, right? So, and roguelike games with like a 3D graphic with Wolfenstein 3D sounds like kind of interesting. Also, working in your browser also sounds kind of interesting. And that's exactly what I'd like to attempt today. Maybe we'll see how it goes, right? So we'll see how it goes. So the first thing we probably need to do, we probably need to make it look like a roguelike, right? So it's probably going to be sort of like a dungeons, right? So essentially you start at a particular dungeon as a dungeon master, right? Like a van. And you have like walls out of stone, maybe some chains and stuff like that. So we'll need to have some sort of like a floor and ceiling, and you go through different rooms, you collect some different items, maybe some keys, maybe some other stuffs, maybe some weapons, potions and stuff like that, and you find a ladder down to the next floor. And then it kind of repeats itself. So you basically constantly going down and down and down and down. And this is not Isaac, by the way. Original Rogue game developed for, I don't know what it's developed for, but the one that didn't even have like a GUI, it was a completely text game. The original Rogue game was basically like that. What's interesting is that if you download the original Rogue game and try to play it, you would be fucking surprised how it looks like basically Isaac. It is actually kind of insane. Like, so Isaac is basically the original Rogue. They just extended it and added shit. Literally, by the way, they literally added shit, the literal shit. So yeah, so I was thinking about something like that. Right. So, but to make it look like, you know, like a dungeon, right, we need to have some sort of like assets and shit. So let's actually go into open game art and maybe grab some free assets, right? So open game art. There's also NetHack, right? So, but NetHack is not the original Rogue game. Right, so Rogue game, we can take a look at it. So the original Rogue game is still available online. It is like NetHack, but it's much simpler actually. So it's from 1980. Yeah, it's pretty old. I really like how so there's like this thumbnail. The game looks nothing like that. The game looks nothing like that. In fact, it looks like, yeah, so this is how the game looks like actually. This is kind of funny, right? So this is the trailer, right? This is the trailer, right? And then down there, this is the gameplay. Oh, hell, you clickbait. I mean, people been clickbaiting since fucking forever, actually. People think that all this like clickbaiting is like a new thing of the modern internet. In fact, people been doing that fucking constantly, right? So it's basically the problem of packaging, right? So essentially, like if you are, look at the supermarkets. The supermarkets, I think supermarkets represent the modern YouTube quite well. Supermarkets like a space where different brands can place themselves, and when the brands, they designed the packaging for their product, they actually keep in mind that their packaging must stand out as the customer passes by, and they need to grab their attention within few milliseconds. And with these kind of limitations, with these kind of technical requirements in mind, they design their packaging. YouTube is literally like that. It is literally a supermarket that allows you to place your products, and you need to package your product so it grabs the attention of the customer within a few milliseconds. It's literally like that. The same with video games. Like it's basically the same game, right? It's a sort of like a packaging game. Right, so, and because of that, people have been doing that forever. Like, as soon as you grab the attention, right, so you kind of won already. You can put whatever the fuck you want in there. So that's the game everyone is playing, and it's not even a YouTube game. It's like, it's been forever. So anyway, if we take a look at this game, we can, as far as I know, there's still source code for this game available somewhere on GitHub, right? So I wonder if we can buy it. I wonder if I can download it. Okay, so we can do something like GitHub Rogue Game Source Code. So original Rogue Game 5.4.4. I never even started. What the fuck? I never actually started. So one thing I remember about this game, by the way, is that it's not compilable as of right now, right? So it's in incompilable state, and you need to kind of fix it first to be able to actually work with it. So I'm gonna give the link to the chat if anyone in the chat is actually fucking interested, and for people who's in the description, right, I'm gonna put it in YouTube. Right, so let me see, let me grab the source code. Right, and I'm gonna just like do git clone. How many commits do we have? Do we have too many commits in here? There's only one commit 8 years ago. One commit. Okay, so we don't have to do a shallow clone, right? So we don't really have to do a shallow clone. We can just clone this shit. All right, cool. Okay, so we've got the source code. And maybe we will need the source code, right? So maybe we're gonna grab, maybe we can steal some ideas from the original Rogue game. Okay, so I'm gonna configure, and let's see what is going to happen. So we're cross-compiling, no, so we're configuring some shit. I really like how Emacs automatically like parses all of this yes and no's and stuff like that and just like displays them properly. That's actually kind of cool, I think. All right, so it generated make files, so let's actually do make, and yeah, so it just compiles all of these things. One of the things I like about the implementation of this game, right, and this is, as far as I know, original Rogue game that started the whole fucking genre. If you take a look at the source code, it looks like a fucking assembly. It's C, but it feels like an assembly, right? So it's just basically like sequence of these like single commands, right? It's like a very old style, like old school C. That feels almost like assembly. I really fucking love it. I actually really fucking love it. So, okay, so it compiles, right? So I remember it had like problems with compiling with all that, but in fact it compiles. So maybe they fixed some problems in here. Anyways, so it just created a single executable, Raguya. Okay, so here's Raguya, so it's a single executable. Does it depend on anything? It doesn't even depend on anything. It depends on ncurses and tinfo and stuff like that, but I mean, that's acceptable. That's in fact acceptable. So let's go into the folder and let's start the game. It didn't fucking start. That's very interesting. So yeah, maybe it's too old. Maybe it's too fucking old. What if it's because of the TeamUX? Can I just start something like oh yeah, it was because of TeamUX apparently. Interesting. It just didn't want to start on TeamUX. It didn't even say anything in there. Yeah, here's the game. Here's basically the game. So as far as I know, you can use arrows, and at is the player, right? I don't really know the controls, right? I don't really know the controls, but as far as I know, yeah, you can do a question mark, character you want help for. Okay, so and then you can read all of the different characters, right? So question mark prints help, slash identifies an object, right? So there is a mechanic in the game that is similar to peels in the Binding of Isaac, right? So you know who played the Binding of Isaac, by the way? So it has this mechanic of peels. You don't know what a peel does unless you take it. So you kind of discover what the effect of the peel is. So there's a kind of similar mechanic in here for items, right? So for weapons and stuff like that. So if you take a weapons, you don't know its stats or anything like that. You have to identify it first. Right. So, and to identify it, I think you have to have identification scroll. I think it's a mechanic from Diablo 2. I think I remember this mechanic from Diablo 2 or something like that. Or yeah. So I don't quite remember, but anyway. So you have different scrolls and stuff like that. Okay. So the star in here is gold. You found 22 gold pieces. And here we have B. If you go into the B, you swing and miss the bat. Okay, so B apparently is a bat, right? To attack the bat, I just go into the bat and I just swing and attack it. You miss the bat. You have injured the bat, and I suppose I killed it. Okay, you have defeated the bat, and there we go. We are alone in this room. So we have a level 1, gold 22, health and strength, you know, arm and experience and stuff like that. So I can now go here. So there is a corridor in here, and it will probably go into a different room. So we have S. So S is probably some sort of a snake. Yeah, it is the snake. Okay, so that's pretty cool. Right, so I keep attacking the snake and I defeated it, and that's the entirety of the game. This is the original rogue. This is literally the original rogue game that created the whole fucking genre of like games, like Isaac, some other stuff, right? So the Isaac's probably the most famous one. That's why I keep referring to it. If you try to play it, you would be surprised how it is like Isaac. It's actually kind of cool. So here's the item, you scale mail, right? So that's pretty cool. But if you press F, I don't know, it asks me for direction. So yeah. So what's funny is that it also here has secret rooms, right? So from time to time you can try to go against the walls, and from time to time you will actually find that walls are like, some of the walls are fake, and you will go through them and you will find a secret room, right? So, and it's step-based, so it's kind of like similar to Eepers and stuff like that, right? So there's the E in here. Okay, so oh, it's chasing me. This motherfucker is chasing me. Holy fucking shit. Anyway, so can I actually quit in here? Yeah. So there we go. We actually quit. So this is the original rogue. So I want to develop something like that, but with these kind of graphics, right? So let me actually show you. So then raycasting. Yeah, with this kind of graphics. So that's what I want to do. So I think it's going to be kind of interesting, right? So instead of like this 2D text thingy, to have this kind of stuff, right? I think that would be interesting, at least to try. So anyway, let's go into the open game art. And let me see what we could even have there. Okay, so we got some subs, by the way. I think I need to acknowledge the subs. So thank you so much, Matthews F777 for tier 1 subscription with the message 66 months starting soon with Zodin. 66 months, yo. 69 soon. Nullifier, thank you so much for tier 1. In Lois, thank you so much for Twitch Prime with the message hey to you too. So Akoe here, thank you so much for tier 1 with the message Adobe Flash game stream web. I don't know, can you even like do Flash games on Linux? Is there any tools that allow you to do that? I think there was something like open source for this kind of stuff, but I don't know. I don't know. It's like the problem with the Flash games these days is that like they're not playable on the modern browsers anymore, so I don't freaking know. Though these days the modern web is so powerful, you can have a Flash player implemented on the web stack itself, right? So you can use probably JavaScript and maybe WebAssembly to implement an interpreter for the Flash things, for the Flash SVF files. I forgot how they were called. And maybe there is something like that for that. Void Manger, thank you so much for your subscription with the message. Could you use the map from the Ada game for this game? I probably could, but I was thinking about a procedure generating the maps. Right, so the thing about the Eepers is that I handcrafted the map. And in here, I just want to procedurally generate this kind of stuff. For those who doesn't know what kind of game I'm talking about, like recently I implemented a game in Ada. Right, it's also grid-based, but it's a 2D one. So it's called Eepers. I'm gonna give the link to the chat, and for people in the description, I'm gonna give it to YouTube. Right, so here is the game. We can take a look at it. So program Eepers, Peepers, and so here it is. So I can try to start this entire thing. This is how the game looks like. So it's a 2D game. It even has a sound, if I remember, yeah. So it even has music and stuff like that. So this is the game I developed. Right. So it's a pretty cool game. I really like the look and feel of the game. Right, so the palette especially. So you're supposed to collect these sort of bombs, right? So then you place the bomb, and that's it. So you go to sort of like a different place in here. So that's the game we're talking about. And it has a map, and this map is actually handcrafted, right? So the map is completely handcrafted. Right, so, and I don't really want to use the same map, right? So it's gonna be a completely different game, I suppose. People are already trying to do Adobe Flash on top of Wasm with Ruffle. The problem is that a spec is like 3,000 pages long and underspecified. Yeah. That fucking sucks. So by the way, if you want to play this game on Windows, you can download it in releases, and also I think it's available on itch.io. So let me see, itch.io Eepers. So here is the itch page. So I compiled the executables for Windows and Linux. So you should be able to actually download this entire thing if you want to play it. It's a very small game, actually. It's a very small game, but it's free, right? So I just developed it because I wanted to try to develop a game. It was super fun. I really enjoy making a game. Maybe I should have become a game developer or something. It's actually super fun to craft these small universes with a set of rules and just observe the emergent behavior of this set of rules. I think it's kind of cool. Why you choose Ada? Why not? Right, because I wanted to try this language, because language doesn't really matter, right? And I kind of enjoyed it. So it's an alright language. A little bit bureaucratic, a little bit enterprising, but still usable. Because NSA suggested it. Yeah, exactly. That's literally the reason. NSA told me, you must use Ada for everything now. You must use Ada for everything. Okay, so what we need to have in here, so let's find some like a cobblestone textures or something. Cobblestone, right? Do we have some cobblestone? Right, so maybe stone texture. Stone texture. Okay, so there's some stuff in here. So we have wall, grass, and your mom's ass. Oh, okay, so this doesn't really look like what I need. But maybe that's alright. Maybe that's alright. What if I put the dungeon in here? Like a dungeon textures. Dungeon textures. 3D castle. This doesn't look like it. So there's an old wall text. Okay. What else do we have? So far only maybe this one is kind of something that could be used by us, right? So if you look at these kind of things, yeah. Old wall. All right, so we have a Wezu text cc by zip, right? Okay, I'm gonna be downloading this thing. I'm already downloading this entire stuff. It's like a 7 megabytes of texture. 7 megabytes of texture. So this is the images. Honestly, I'm probably gonna have a lot of different assets for the game, so I would like to introduce the assets folder, and I'm gonna move the images into the assets folder, right? So I'm gonna move it like that. So now in here, what we need to do, I'm going to go into the downloads, So here is the thing. I'm gonna literally move it in here. And what I'm thinking is that, can I just take, yeah, so here it is. Here is this stuff. Credits.txt. I don't want to lose the original pages of the assets that I'm using, because I want to keep keep the links in the credits, right? So because of that, I'm trying to be like a super careful and stuff like that. Open game art. So this is open game art. I'm moving that stuff in here and maybe this stuff in here as well. So let me see what's inside of this entire thing. Okay, so there's no zip bomb. Let's actually unpack this entire thing. So what do we have in here? So there's a wall in here. Okay, that's pretty cool. So there's a wall. Oh, it's a normal. So we don't really need normals, though. This is interesting, chat. Has anyone actually tried to use normal maps in a raycaster? Wait, what the fuck? It's not even that hard. Has anyone ever thought about, like, I mean, the normal maps were developed like way after people kind of abandoned raycasting, so like never needed to do that. This is such an interesting idea, like use normal maps, because like with a you're probably gonna have some sort of like a lighting, and it's not that hard, right? So essentially you figured out the strip that you need to render, right? You figured out the strip that you need to render. You take the strip from the normal map, you reinterpret the colors as the normal, right? And that's how you sort of change the coloring and shit. That is a very interesting idea. So I think I'll write it down. I'm not sure if I'm going to try to implement it, but I can try to implement it at some point. So what is a shaga? N is a normal map. So what is shaga? Does anybody know? Does anybody recognize? I'm not a game developer. I don't recognize this kind of thing. So does anyone know what kind of thing it is? Right, because normal maps, they do have some sort of like an iconic look. Right, but this thing, I do not recognize that. So maybe we can try to Google it up. Shiga map. Shadow something. Okay, so it could be. Interactive map. Okay, maybe normal maps. And... Ooh, normal map. Shadow global something something. Maybe some kind of baked occlusion map, maybe. Again, I'm not a game developer, so I do not recognize this kind of thing. But it's kind of nice that we do have this kind of stuff. So this is the color wall 3. This is a broken wall. Okay, that's pretty cool. So that may work out. So in the color 4. So we can try to use this kind of stuff. We can try to use that. Okay. So let's go and maybe try to use this kind of walls. So I'm gonna go to TS and let's just load some of these assets. Oh, by the way, those things are not correct anymore. So now they are located in assets, right? So it's now images and stuff like that. Oh, it's kind of interesting, like recently off screen I implemented this kind of thing. So if you have assets that are not loadable, they're going to be replaced by a purple block, right? So essentially, if I just try to open this kind of thing right now, let me actually restart. So as far as I know, I killed the... oh, this thing, yeah, this thing doesn't work anymore. Yeah, I killed the server, so I need to kind of restart this entire stuff. So npm run watch. Right, so I implemented recently watch mode for the entire project. It's actually kind of cool. I can show you how it looks like. So a watch subcommand actually runs watch.js. So, and it's a custom script that runs first TypeScript in watch mode and HTTP server, and just keeps them simultaneously, just runs them simultaneously. It's pretty convenient. So there's a little bit of a wrapper code for starting commands and stuff like that, but it's a custom like a watch mode. Right, you know how modern frameworks, they have some sort of like a serve watch mode, right? So you just start it and it just brings up your entire development environment. You just open it in the browser, you modify something, it automatically reloads and stuff like that. I can do this kind of shit myself. Look at that. I'm a web developer. It's that fucking easy. You just spawn child processes and there you go. So Not even using, exactly, I'm not even using Vite. You can just do all of that shit yourself. Like, come on. You can just do that shit yourself. I think that's pretty cool. I think that's pretty poggers. Yes. No Webpack. I'm not using Webpack. To be fair, the entirety of the game is just a single JS file, so I didn't really see any point in using Webpacks, right? It's literally like a single file. Unless I will start like separating into different modules, I don't see any reason to introduce any packaging or anything like that. Yeah. So anyways, so we got that. If I refresh this entire, yeah, as you can see, all of them became purple because it couldn't load them, right? So it literally couldn't load them. So now I want to try to fix this entire stuff, right? So let's go ahead and fix all of these things. So it's going to be assets. There we go. And I'm going to refresh this entire thing. And did it work? It didn't fucking work, mate. I wonder why. Because it's asserts. Jesus Christ, bro. Okay. Yeah, now we're talking. And now we're fucking talking, man. All right. So what we need to load in here, we need to load the wall. I'm going to go into the assets, images, open game art, and this thingy majingy. And I'm going to just do that. So this is going to be assets. This is the subpath that we have in here. Const wall1 load image data. Put it in here, and here is the wall that we're loading. So it's a asynchronous call, so we have to do await because this entire thing returns a promise. Yeah, it does return a promise, and if it failed for whatever freaking reason, we're gonna just replace it with a color purple, like so. So we'll get a wall. So this it compiles without any errors, right? And let's replace this studying pog with a wall1, like so. And let's go ahead and refresh. Okay, so doesn't look half as bad. What the fuck? What the fuck, chat? Why is it? Okay, what if we replace all of them with walls and stuff, right? So this is gonna be wall1, 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 wall1. Yeah, let's go. Very dungeon-like, exactly. It does fucking feel like dungeon. Holy shit, I love it. I love it so much. So, but this is only like a 4 walls and stuff, right? So it's only like 4 of them. So let's actually load the rest of the walls. So this is gonna be wall 1, so this is wall 2. Right, this one is wall 3, and this one is wall 4. Wall 4. So for this one, we can just try wall 2, wall 3, and this one is going to be wall 4, just to see how they look like. Yep, they look differently. All right, so this one doesn't... Okay, so this is actually kind of cool. You can add a little bit of a variation to the walls in here. That's for sure. You can add a little bit of a variation. Okay, this is like a very special wall. Yeah. That is so fucking cool. So this one, yeah, so there's another variation. So it's two different walls in here. But this kind of stuff, I think it's okay for like a different floor. I think it's okay for a different floor. So yes. So there's a little bit of a problem here. We can go through the walls, right? So which actually like breaks Raycaster. I think one of the things we should try to do is to make the walls impenetrable, right? Because as soon as you go into the wall, like it's impossible to get it out, like you don't know where you are, unless you're looking at the minimap. So one of the things we probably have to do, you have to add impenetrability, so to speak, of the wall. This is so doomy, yeah, because we're using kind of the same technique that Doom used, which is raycasting. So I suppose we don't need to load any of these things anymore, right? So we don't really care. We only have walls and stuff. We only have walls. So let me do a committee. I think committee as of right now is going to be a good idea. In terms of assets, I'm not sure if I want to commit the entirety of this stuff. I probably don't want to commit the zip, right? So I really don't want to commit the zip. But the PNGs and stuff like that, I think it's going to be totally fine. So, and also these kind of things. All right, so they were renamed and everything. Okay. Add dungeon wall textures and stuff. Dungeon wall textures. I'm gonna push that right into the repo. Make the walls impenetrable, unlike your mom. God damn it! I taught you well, chat. I taught you well. Doom didn't use raycasting actually. I have no idea, honestly. I never played Doom. Believe it or not, it kind of went past my childhood. Unfortunately, it really went past my childhood. Thank you so much, D. Jugenson. I hope I pronounced your name correctly. Thank you so much for your one subscription. Thank you. What? I'm sorry. Like my first PC was Windows XP. Was on Windows XP. Like Doom was like completely like an old thing at the time. So I'm really sorry that I was born in a poor country in a poor family in a third world country. I'm really sorry about that. Should have picked a better location. Sorry. The first PC was Raspberry Pi. Cool. Anyways. What do I wanna do in here? So we are, yeah. So we need to make the walls impenetrable. Honestly, we need to make the walls impenetrable. How we are going to do that? Let's open my paint. Let's open my paint. Technically, Russia is the second world. Maybe I don't fucking know, and I'm not sure if I care. So we have a grid, mother flippers. We have a grid. So, and essentially, what we can do. So we have a position of the player, right? We have a position of the player in chat, and let's actually denote the position of the player like this. So here's the player. So every time we're about to update the position of the player, we can just take the position of the player and see if now it points at the cell that has become impenetrable. Unlike your mom, right? So this is impenetrable, like this. And so there is somewhere a place in the code where we update the position of the player. There we go. So here we update the position of the player, adding the velocity scaled by data time. We may try to do a very interesting thing. We may actually assign it to a new position, right? So this is a new position now, right? And the player position equal to new position, but we're only gonna do that. We're only gonna do that if position does not point to impenetrable wall. You know what I'm talking about? You know what I'm talking about? Yeah. How can we check that? First of all, we need to check if the position is within the scene. We don't want to do out of bounds or anything like that. By the way, can I actually do some shit like this? So if I have a node and I have an array. Right, and I try to get shit out of bounds, so it's undefined. But in reality, I actually have a two-dimensional array. So that means sometimes I have shit like this, right? So that means sometimes I may get an empty array, or sometimes I can get undefined. So if I try to get, yeah, so I get a type error, so I literally get an exception. So that makes it kind of difficult, right? So that makes it kind of difficult. It would be kind of cool if it's out of bounds, it always returns undefined, but I mean, in that case, it's not going to really work that well. Anyway, unless we actually store everything in a straightened up array and actually compute the indices ourselves, right? We can do that if we wrap the array into its own thing, but then I don't really want to do that. Anyway, so here, I think we have a function inside scene, right? So there's a function inside scene. Yeah, there we go. So this is actually a pretty cool function. So it accepts the scene, which is an array of cells. Might as well actually introduce a cell. All right, so it will probably make it a little bit easier to read. Though null cell Yeah, it's totally fine. So it's either null or HTML image element or a caller. Right, so it's basically an array of cells. We check whether the point is within this entire stuff. All right, and in that case, it returns you true if it's inside of the scene. Okay, so if inside scene new position and scene new position y, new position x. Y comes first because first come rows. So first the rows, then the columns, and that's why y first, because y is a row. Row, 5 the power. Right, and essentially if we're inside of the new position and the scene is not equal to fucking neighbors, motherfucker, it's not equal to null, we don't want to actually assign the new position. Right, so, but why kappa? It's a good question, actually. I don't know, because I kind of got used to that. Because I think of the arrays as the C arrays, because C arrays, they're like located row-wise in the memory, and I kind of got used to that. So in modern enough JS, you can do question mark thingy. It's the, is that the LV separator? Yeah, this is the LV separator. If I know this. Oh, LV separator is actually like this. Yeah, that's the LV separator. This is not an LV separator. I don't know. We can give it a try. So let me see. So if I have something like this, and if I have like 10, and right, how do you do that? So it's probably something like. Okay, so that's very interesting. So what does it do in here? It expects you. So it just first checks. Okay, so we can try to do that. That sounds interesting. It's a pirate Elvis separator. Yeah. Yes. So that sounds kind of interesting. So we can try to do that. We could try to do that, but I already kind of done with that. So anyway, so essentially we can do something like this. We can negate that, and there we go. So maybe we can do apply the Morgan law, but I mean, I think that's fine. I think that's fine to actually do it like that. All right, so this is compile. So I think it doesn't, no, it doesn't compile. So expected arguments got 1, 396. So what's up with that? Oh yeah, you're supposed to supply a scene. Are you okay now? You are in fact okay. All right, so let's refresh everything. So there is an error apparently. So let's take a look at the logs. Cannot read properties of undefined 396. Oh, right, that's kind of bizarre, right? So because I know the shed is inside and cannot read properties of undefined, reading 5. Oh, okay, I see what's going on. Yeah, so because this entire thing is fractional. So one of the things we need to do, we need to actually know what cell it is hitting. So we have to do something like math floor, right, like this. But at the same time, we also have to actually check that we're within the scene with also floored new position. So it would be kind of nice to create a separate new position, like a new cell position, right? So this is just like a regular continuous position, and this is a new cell position, which you just do something like this, new position y, and this is just like a math floor. Maybe chat, we have to create a new method for floor. We need to create a new method for floor, something like a new position. Round, no round. We actually have to round down always, which is floor. If we do something like floor, new position floor, is that a good idea? Or we can even go much cooler. What if we implement map like this? I think that sounds actually kind of cool, right? So you just map, and it's just like math floors, like both of them. And then you can just use this shit like that. New cell position, like so, and there we go. So guys think. So fly check mode. We're doing pure functional programming, motherfuckers. We have map. Look at that shit. So, well, we haven't implemented it yet, but we're about to implement it. Don't worry about it. Don't fucking worry about it. We're gonna implement the map. So in here, we're gonna accept f, which is a function that accepts a number and returns you another number, right? And we're gonna just return vector 2, which is effectively just new vector, this x applied f, this y. How cool is fucking that, mate? Fucking that, mate? Okay, I'm sorry. How do you define? Okay, so this is how you define a function. Okay, so fly check next error and no errors. So we actually implemented that. Mono, yeah, it's not really mono. It's a functor actually. This is a functor. It's not monoid nor monad or anything. So it's just a functor. Yeah, because we can do map and shit. Anyways, so we get that. So is it working? Is it working? It compiles. It seems to be compiling, and there we go. Okay, so that's cool. Let's see if it works. Technically, it works. As you can, if you look at the minimap, right. So if you look at the minimap, it does in fact work, but the view still kind of penetrates the wall, which doesn't really help with like this warping of this stuff. So what's funny is that I feel like, yeah, the problem here is that we're treating the player as a point, which is not correct. I think the body, the player should have some body. It should be a little bit thicker, just like your. Anyway, so the player should be a little bit thicker, so it's not like a point, so it doesn't really penetrate the wall. So I think we have to treat it as a circle, right? So it's probably like a circle, so it's from the distance of the wall. Girth the player body, yeah, exactly. So he needs some padding, yeah, exactly. It needs some padding. So I wonder how we're gonna implement that. Just like you, got him, oh, yeah, that fucking sucks, honestly. Yeah, I mean, technically it works, but it's just like the warping is not good. The warping is definitely not good. It's just like not happening at all. But it's close. It's actually close. I think it's pretty close. So one of the interesting thing. So we have a lot of these helper functions that kind of associated with the scenes and stuff like that. And scene is not necessarily like a 2D array. I think the way we talk about the scene is not particularly great. I think it is not particularly great. Right, so maybe we need to actually refactor the scene to be something more interesting. So maybe it could be a class. So this is a scene, and it actually has like an internal cells. Right, so it's going to be cells, and let's say it's going to be array of cells. Right, so it's an array of cells. And we have a constructor, and what we accept in here, we just accept an array of cells. But on top of accepting the array of cells, I think we should accept the width and height of this thing. Right, so it's going to be width, which is a number, and height, which is a number. And we can store all of these things in here. Why is it still out? It's complaining because there's a collision between the names and stuff like that. So it's called scene2 electric boogaloo. So, and also we want to keep the width and height like this. So now I can just do something like this. So it's going to be cells. So cells, and then here we're going to have width. Here we're going to have height. So the thing I want to do, by the way, I want to have some sort of a getter, right? So you do... What's up with that? So get... So does get has some sort of like a special meaning in JavaScript? Does anybody know why is it highlighted like that? I don't know how to program in JavaScript. Like I just want to have get. Yes. So what does it mean? What does it mean? JavaScript get. Well, chat, you're so fucking helpful. Thank you for... Classic chat. Okay, so I mean... Syntax binds an object property to a function that will be called when that property is... Okay. So it's a bruv, bruv. Okay, I don't like it, but I mean, it's just like, why did you take away such a freaking useful shit from me, bruv? Such a freaking useful shit. Anyway, whatever. I can do get some. Fuck you. So, and in here, what we're going to be doing, we're going to be accepting the coordinates, the point, which is like just a vector and shit like that, and we're going to just return a cell, so we can get a cell. Git, yeah, that's a funny one actually. Git, yeet. Yeet is when you remove an element from a container. It's like a property decorator in Python. Python has a property decorator. Honestly, I never bought into this property stuff in all these languages, so I really don't really care. So, if I remember correctly, I remember properties from C#, I think. Yeah, so essentially you can have a property, you can have setters and getters, and this is just like a syntax sugar for actually calling those things. So this is actually the syntax sugar for calling them. So anyway, we can even do something cool, right? So cell or undefined. So if you're doing out of bounds shit, you're gonna do it like that. So we can also do something like contains, which accepts this thing and returns you a boolean. Which returns you a boolean, and it's effectively inside scene, right? So it's in fact effectively inside the scene, and also scene size is a thing that just computes the size and returns it as a vector. Honestly, since we store the size like this, like it's not needed anymore, right? So yeah, so it's totally fine. Okay, so let's do something like this: px and px is less than width, and 0 less than equals py, and py is less than height, and obviously all of that has to be part of these. So, and essentially if you know, these contains p, does not contain p, we return undefined. If it does contain p, what we're doing, we just do these cells py multiplied by height plus px, and we just return this kind of thing, this height. Yeah, that's what we're doing here. That's what we're doing. It's pretty cool. That's pretty cool. Interestingly, do I want to floor these things? So essentially, do I want do something like this, like a v fp, let's call it fp. So you map it with math floor, and instead of this kind of thing, you just use fp. I think I kind of want to do that. So essentially you just have a point and you access the cell at that point, regardless of whether it's like has fractional part or anything like that. Right. So it's kind of cool actually. Right. Just a second. Yeah, that's pretty cool. So maybe the time has come to make a small break. I think the time has come to make a small break. I would like to make a cup of tea, honestly, but it's super hot right now, so yeah, I probably won't be able to actually drink it. So yeah, I'm only gonna pour myself like a little bit of water, right, you know, wander around, think about the problem, and then we're gonna continue a little bit later. All right, let's make some break, and all right, let's continue. So yeah, we have a scene 2. In fact, maybe I'm gonna get rid of this scene. So I want the code to break everywhere we were using this original scene type. So instead of that scene type, we're gonna be using this one, and we'll see if it's gonna be convenient or anything. So yeah, we'll already check whether something is inside of scene. So the equivalent of this function is this one, right? So we don't have to do that. So there's also scene size function. It basically tries to compute the size of the scene. We don't really need that as well, right? Because now what we can do, we can just do size, and we can return a vector of these things. So we return new vector to this width, this height. All right, so let me go through the compilation errors. Right, so I get rid of the previous scene type, I replace it with something else, so everything is broken. So let's do compile assisted refactoring. Okay, so this one is pretty cool. Scene, you have that. So the cool thing, what we can do now is that scene essentially get cell C, and funnily enough, it will return you undefined in case of this thing not being available, right? Because that's how this get cell works, right? First of all, what you have to do is probably check that it's not undefined, and it was actually kind of lagging. So if it's, we're kind of stopping when this thing is equal to something, or Emacs is actually going crazy right now. I don't fucking know. So it's inside of, so we stop when it's inside of the scene and not equal to null. So what that means is scene gets cell C not equal to undefined, right? So not equal to undefined and not equal to null. Right, it's kind of interesting. Undefined means that there's no such cell. Null means that the cell exists, but it's empty. So it's kind of like we have two separate meanings for these two things. It's kind of funny, actually. So if it's, right, we keep continue moving when it's that. All right, so that actually makes sense. Okay, the next error. So here we get the scene size. So we can just do size, and that's fine. All right, so we get the cell. Which is understandable. And then, so we can just do something like get cell new vector x, y. Right. Next error. Here we check that we're inside the scene. Okay, this one is rather interesting actually, because we can simply just do that, get cell C, and basically a lacking cell is going to be one of those things. Yeah. So this is basically what's going on here. We have to align everything properly. Okay, this is actually way more convenient. So you get the cell. If it's color, we're going to do one thing. If it's not, we're going to do another thing. If it's null, we don't draw anything. And if it's missing, we also don't do anything. All right, so that's actually kind of cool. That's way better approach in here. So here the scene size, I take the size of the scene and I scale it by the cell size. Okay, so that's also understandable. And here we construct, okay, so this one is really interesting. So I need to construct a scene now, right? So it's a new scene, and one of the things I pass in there is the cells, but the cells that we accept in here, it's a flat array. Right, as you can see, it is a flat array. So now what I have to do in here is probably just do something like this, and I also need to get rid of all of these things. So I wonder if I can just do something like that. All right, so that gives me this kind of array, and I need to know how many columns I have in here. So this is the 9 columns. Amount of rows is also rather interesting. You know what? Yeah, I guess that's fine. So this is gonna be, I really don't particularly like that, honestly. I really don't like that. So width, so this is the 7 lines, so that means it's 7, 9 and 7. I really don't like that I have to compute this kind of shit myself. Right, I really don't fucking like that. So what I probably want to do, at least for this specific constructor, is actually go back to this kind of thing and maybe compute width and height in the constructor itself, and then just store flattened out thing. Right, so just accept this kind of thing, and I compute width and height myself in here. You know what I'm talking about? You know what I'm talking about? So yeah, how we're gonna be doing that is rather interesting. So let's give it a try. So essentially, we can easily identify the height. It's not that big of a deal, it's just a cell's length. So this is the height. So then we have to compute the width, and width is going to be the maximum width across all of the rows. It's going to be the maximum width across all of the rows. So now, what we're going to do, we're going to actually take the number minimum, like it's a mean value, because we're going to be computing the maximum. And I'm going to be iterating through all of the rows. All right, so the row of cells, right? So I suppose this is how we do that. And then what I can do in here is this width math maximum between the width and the row length. Length I set Emax. There we go. So and that way we have width and height. So this one is rather interesting because this implies that the rows can be of different width, right? So, and the actual width is the maximum one. So what we're effectively doing, we are allowing the user, new size, to maybe have a little bit less of these things in here, and the whole thing is going to have the width of the maximum one anyway. That's what we're doing, right? To the people in the chat who's saying, I just use array flat, blah, 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 blah. We are taking this kind of case into account, right? So this thing can be of different size. If you do not pad them properly, you can't easily use array flat, right? So we have to be really careful with this kind of shit. So how we're going to be doing all of that? I suppose we're going to be, since we know the maximum width and stuff like that, we're going to be iterating through the rows yet again for the second time, right? So we're going to be iterating through the rows for the second time, and we are going to just append them into these cells, right? So I suppose initially I can say that this thing is going to be just empty, right? And how we're going to be appending all of that stuff? That's a very interesting question. So can I do the thing? So it's not Python. So if I have something like this, is there any way for me, for example, I can do append, or what is it called, push, right? So I can push a little bit of this kind of stuff, and that gives me that. And can I now say 5, 6, 7? It is not going to actually do this. Yeah, so it's going to do it like that. So we probably need to concat the whole thing. But it doesn't really matter. It doesn't really matter. So what we can do is just cells, maybe concat row, right? So if I understand correctly, so 1, 2, 3, concat 4, 5, 6. Okay, so that explains it, right? And I suppose I also have to maybe even reassign this kind of thing, right? So we concatenated this entire stuff, and then we have to push the tail, so to speak. We have to push the tail. So what's going to be the tail in here? The tail is effectively the width minus the row length, right? So that's basically the tail. And we can do something like this, right? So this is the rest of the stuff, and we just do push null in here, and there we go. So that's basically what we're doing here. So we realign all of that stuff, right? So we realign all of that stuff, hopefully. Okay, so does it compile? So let's actually kill the whole thing. So I removed the compilation of the thing here, right? So, okay. Starting compilation in watch mode, it doesn't compile, right? So we still have a bunch of things that we need to fix. So next error, so this is a scene size, right? So we continue doing with this kind of thing. And the next thing here, so we're checking that we're in, okay, this one is interesting. So this is what we introduced recently. This is what we introduced recently. And the way we now handle the scenes allows us to just do get cell, new position, and we don't even have to floor this entire thing anymore because it's floored automatically inside of the get cell, as you can see. And if this thing is missing, it's going to just return undefined. And what's funny is that this allows us to replace the whole thing with the following stuff. If this thing is equal to null or undefined, we just continue, right? So we can say equal to null or undefined. So it would make sense maybe to just save it like that, so we do not recompute it over and over again. Undefined, like so. All right, so that looks pretty cool. And no fly check errors, everything seems to be working, everything seems to be twerking. I hope I didn't break shit. So let me now try to, to open this entire stuff. So let me open the DevTools. I want to like refresh with cleaning all of the caches and shit, right? So all of the caches are cleaned up. And yeah, something is absolutely broken. Something is absolutely broken, but not really that much, honestly. Not really that much. So let's actually see if I made any error in the scene. Okay. So, okay, height is the amount of these things. Cool. So the width is the maximum among all of the rows, right? So we pick the minimum value to make sure, right, to make sure that it's going to be picked up. So we find the maximum among all of these things. Then we take these cells, right? We are assigning like empty array in here, and we are iterating through the rows one more time. So then we take these cells and we're just appending all of the rows that we have in here into that thing, and we are reassigning it. And we're padding the rest of the stuff with this kind of thing. So I'm not 100% sure what exactly went wrong with this kind of generation, right? So it doesn't look like it. It's kind of close to what we want to do, but not really, right? It's completely fucked up. So I don't see the problem with this. Like, what's actually the problem? We can try to maybe debug this entire thing in a sense that when we do that, we could print its size. Console log this width and this height. So what's up with this kind of thing? Let me go here. Sir, what the fuck are you talking about, bro? Okay, 9 and 7. Okay, so all right. So what's up with this shit? I literally don't see a problem. I literally don't see a problem. So that means the problem maybe somewhere with get. Found it. I was right. There was no problem in the constructor. Pretty cool. So console, yeah. Okay, so that explains it. Fix it. Okay, so the problem was within the get cell. Perfection. Nice. Alrighty. That's pretty poggers. So yeah, we still kind of penetrate through this entire thing, but that's totally fine. So we need to add a little bit of a girthiness into the player. So before I add a little bit of a girthiness, I think I need to maybe do a committee. Because we just introduced like a whole new type for this scene, for managing the scene. And the cool thing about this type is that it kind of abstracts away completely the way it stores the cells, right? So essentially, if we're gonna store the cells in a more sparse way, we are not gonna be changing any of the code that uses the scene. Right, so the code that uses the scene and calls to get cell, it doesn't really care how exactly the cells are stored. They could be stored in a very sparse way, right? Maybe like a hash map that maps specific X and Y coordinates to a particular cell and stuff like that. So here we're actually storing everything, but maybe if the scene is super huge, it's not necessarily going to be like a plain array. It could be maybe some sort of a tree or something, right? So we'll see. But I don't think we're going to have such scenes. Because it's going to be probably simple, like a browser game, so you don't really need this kind of stuff, but still. Maybe. I don't freaking know. Okay, so let's do a committee chat. Get ready for a fucking committee mate. So introduce refactor the way we store the scene. Store the scene in a plain array. I'm gonna push that right into the repo. A little committee, and maybe even a tiny pushy. Exactly, my friend. So, what we're gonna have in here? So we probably need to introduce some sort of a radius for the player. So I feel like the radius of the player has to be less than a cell, because I want to be able to kind of stand in this sort of like pocket in here, right? So here is the minimap, and in this minimap there is this sort of pocket. I want to be able to stand in these kind of pockets and maybe like wander around within this cell, maybe look around and stuff like that. Because of that, the radius of the body of the boundary of the player is going to be less than 1, because the size of the cell is 1. So, which makes it kind of easy to check whether the player is intersecting anything, right? Because if the radius of the player is less than the cell, it's not going to be touching more than 4 of the cell at once. In fact, the way we can check that, right? So, the way we can even check that, That is kind of interesting. So maybe we could use an algorithm that checks the intersection of the square and not square, but the rect. Is the player round or square? I think the player is round, but we can try to make it square. So I'd make a player square rather than a circle. I feel like I want to make it circle. But we can try to make it square. Yeah, so I feel like square is going to make it a little bit easier to work with. Minecraft style. So in Minecraft, the boundary box of the player is like squares, right? So it's basically rectangle and stuff like that. We can do that. Why not? I think it's going to be actually fine. Player size, right? So, and the player is going to be square, right? So, and we're going to use size as width and height as well. So, what's going to be that thing? So, let's say that is going to be maybe half, right? So, and I think it has to be reflected in the minimap, right? So when we are rendering the minimap, we're rendering the player in here, the position of the player. So yeah, as you can see, we just do the circle of the player, right? We just do the circle of the player. But let's try to do the rectangle. So ctx fill rect. So it's going to be ctx, and we take the position of the player. So this is a player position x minus half of the player size. So essentially, within the boundary box of the player, the position of the player is going to be at the center, right? So this is going to be at the center. So because of that, so when we're rendering this entire thing, we're subtracting half of the player size from x, and in terms of y, we're also subtracting half of the player size. Might as well even do something like this. So, and then width and height is going to be player size, like so. And this is how we fill the rectangle. So, and I want it to be sort of reflected in the minimap. Right, so, okay, do we see shit in here? We can't see shit in this mist, which is kind of surprising, honestly. So, maybe because it's so goddamn small. So there's, okay, so there's a problem in here. Player size, you don't like the player size. What? Because yeah, you don't do it like that. I see. So that explains it. Yeah, there we go. So this is the size of the player. So it's kind of like makes it difficult to see the field of view of the player unless we actually increase the near clipping plane to something a little bit bigger, maybe half. Yeah, so let's refresh. Yeah, so now we can kind of see that. Yeah, there we go. So that makes sense. So, but I have a feeling that it would be kind of better if the player was actually kind of circle. From the field point of view. Yeah, so it's already starting. So the near clipping plane has to be like a quarter, I think, for it to work a little bit better. It's already... Oh, yeah, I forgot to do this. Maybe it has to be even smaller, right? It has to be within the boundary for it to work properly, I feel. Yeah. Okay, so we can't see the FOV of the player because it's within the boundary of the player. So, and because of that, when we actually implement the collision, you know, colliding with the walls is going to work fine. Okay, that's kind of a funny way to do that, but I'm fine with that, sure. It's just like I kind of don't like that I can see FOV in a minimap, but we can have like a fake clipping plane to just show the cone, if you know what I'm talking about, right? We can have fake thing in there. Anyway, so what we can do, we can now, since the size of the player is smaller than the cell, we can just check 4 points and check if we intersect with any of the walls or anything like that. So to be fair, maybe we could even implement something like sin and like isWall p vector 2, which returns a boolean. And the way we can do that is essentially this get cell p not equal to null, and this get cell, we might as well even extract it to a separate c in here, c not equal to undefined, right, something like this, right, isWall, which makes it possible to do things like this, sin isWall new position. Yeah, we can do shit like this now. So this is the new position, but within the new position, we need to figure out the 4 points in there, right? So essentially what we can do a new position, and honestly, player size. What if we treat the player size more like new vector 0.5? Something like this, but we can't construct it, but it's just like what I want you to do is essentially subtract you know, new vector 2 player size half of this entire thing, and it's just like not particularly convenient. So what I was thinking, it would be kind of cool if vector had a constructor that construct a thing from a single component like this, so I can then scale it by half and then subtract. Like, what would be a better name for this kind of constructor? So single, basically it takes this thing and fills up both x and y with that value. I think single is an okay. Maybe okay, from scalar fill. But the fill is not a constructor. Fill is a modifier over existing containers, so it's not going to work. It's not going to work. So I think from scalar is actually better. Class vector 2. Okay, so because we have, oh, we even have this kind of stuff. So 0. So vector. Okay, so I think I know how to call that scalar. Scalar, and we can have a value and number. And we just return a vector 2. Right. So now I just return new vector value, like so. So it was called from scalar, scalar. Yeah. So vector size, scale by half, and since we have a scalar, we can actually make it shorter. You don't need to scale anything, and then we subtract this entire thing, and we have like a left point in there. So now I could probably save this entire thing to something as just like it's more like a corner, if you know what I mean. So, and then we can simply like iterate all possible combinations, right? So 0, 1, and stuff like that. So how can we even do that? So we can have x, which starts at 0 and less than 2, right? So because I want it to be 0, 1, right? So in here we're gonna have y like this. So, and that's basically offset. I would even call it like dx, maybe. Not even x, just dx and dy. Dx and dy. Alright, so, and the vector that I'm interested in is dx and dy. So in a corner, I would like to maybe add this entire thing, but at the same time, I would like to maybe scale this entire stuff by the player size. Alright, so I scale it by the player size, and then I add it to the corner, and this is like one of the values that I have in there. And if scene is a wall, we don't want to move in there, which implies that this entire thing has to be some sort of the function, right? It has to be some sort of a function. What kind of function should it be, right? So it's a function that accepts a new position, which is a vector 2. So it probably also accepts the scene, right? It also accepts the scene, and it returns you a boolean, which means, right? It checks whether you can go there. Can player go there? Good name for a function. So, and this entire thing is going to be basically part of this function, right? So we have a new position, you have a scene and stuff like that. If in that specific corner you find something that is a wall, you insert a return false, and in here insert a return true, something like this. It's like a very dumb, simple function. And now can player, I want to grab this entire thing. So we figured out the new position, we pass the scene there, we pass the new position there, and if we can go there, we assign the new position there. If we can't go there, we don't do anything. So that's basically what we can do. I ran out of Flora, unfortunately, but anyway. So let me see. Does it compile? It seems to be compiling. Everything seems to be working. Everything seems to be twerking. So yeah, it works. Look at that. It kind of works actually. Yeah. So if it was like a circle, I think it would be a little bit easier because you could sort of like slide around this entire stuff. Yeah, I think that would be much easier, but this also works for now, right? This also works. So as you can see, I can like wander around within that pocket and do some different stuff. But it would be way better if the player was a circle, honestly, just saying. I think it would be way better. Right, but we still have this kind of thing. We still have this kind of thing, so that's pretty cool. That's pretty cool. That's pretty cool. So yeah, let's do a committee. All right. Excuse me, Jesus Christ. So get cell, blah blah blah. Okay. Give player bounding box. Give player the bounding box. One thing I probably want to do actually. Try circle boundary instead of a box. I think for a player it would be much better. But I don't really want to spend that much time on figuring out how to do circle and stuff like that, because we already have something that works. It doesn't really feel good, but we can always fix that. Right, so let me do the following thing. So I'm going to actually amend that because I didn't push anything, so let's push that right into the repo. Okay, that's pretty cool. That's pretty cool. So what else do we need? What else do we need in this entire stuff? Maybe we could try to implement floors and shit. Implementing floor should be pretty easy, honestly, right? So you just do what? Where is the render game? So you render the scene, you render in the minimap. Before you render the scene, you can always do some interesting stuff like CTX fill rect, and you basically fill bottom half with some sort of a color, right? You fill the bottom half with some sort of a color. And what that color is going to be. So position is going to be x0 in terms of y, it is going to be half of the height. So we take height and we take half of the height, like this. In terms of width, it is going to be the entirety of the width. This is the entirety of the width. And in terms of the height, it's going to be half of the height, right? So it's like at the bottom thing in here. So, and then we can do CTX fill style, and we can maybe make this entire thing a little bit more bright than the background. And this basically becomes the floor or the sky. Right, so and if I refresh, yeah, there we go. So that was easy. So floor is super easy. If it's a solid color, if it is a solid color, it is super easy. And since it's a sky, we could have actually could have swapped this around so the sky is a little bit more bright in that specific case. Yeah, so that makes a little bit more sense. That makes a little bit more sense. And maybe for this thing, we could have just used like a bluish color. But unfortunately, talking about the specific hues is not convenient. It is not convenient because in RGB, right? So because we're talking about RGB, we probably want to do HSV in this specific case, right? So that means we need to introduce some HSV. So we have a color, honestly, but which is RGB. It's RGBA. You know what I'm thinking? So let's actually query replace color with RGBA. Yeah. So that's what we're gonna have. This is RGBA now. So then we can have HSV. Yeah. I'm not sure if it's a good idea generally to have it like that, but I mean, it's fine, I guess. So class HSV. So, and as far as I know, the style has HSV, right? So CSS HSV. CSS, it's HSL. Okay, HSL. So it's not HSV, but do you have HSV? It doesn't really matter, right? So it's pretty much the same thing. There are some differences, but it's fine. So there's also HSLA, so for the alpha, so you can have transparency and stuff like that. So yeah. That's literally how I feel right now, right? Doc not hell. All right. So HSLA, so it's gonna be H. And what are the parameters, right? So they are percents or something, right? So they are percents. And in case of HSLA, it's like from 0 to 1. Okay, so that makes sense. Though the first parameter is not percent. Look at that. It is not percent. What is it? Do they say? What is the hue? Hue is a degree from 0 to 360. Okay, so that makes sense. That makes sense. Okay, so this is a number. HSLA. All right, and so let's just create le constructors. I'm not sure if I want to copy paste this entire stuff, but I mean, whatever. Let's just copy paste this thing. HSLA. Can I just do some HSL, and there we go. So, and another thing we can have in here is probably the style. And here's just H, so HSLA, HSLA. So we'll also have floors in here. Do we want to have floors in here? I'm not 100% sure. I'm actually not 100% sure. Why the fuck am I doing that? Can anybody fucking explain me why the fuck am I having this class if I could have just like render scene, actually render game? I could have just like directly used this shit in here. Like, what the fuck is wrong with me? Anyway, whatever. Like, let's forget that you saw anything in here. Right, so this is 0. So saturation, we're gonna have like a fair amount of saturation, like maybe 100%. Lightness, I don't think we're going to have too much lightness, right? So it's going to be percent, and here is going to have 1. Right, so this is red. If I remember correctly, the degrees of hue 0 is red. So we'll have to adjust it to be, yeah, I didn't want to close this entire thing. Wait a second. Yeah, F5. Yeah, so this is red. And what I want to do, I want to kind of maybe run 20. So this is, yeah, so this is greenish, maybe 220. Come on. Yeah, something like that. So it's, to be fair, it's a little bit too saturated. Let's actually desaturate this thing. So maybe 60% of the saturation. 60%. So did it work? Doesn't feel like 60%. Maybe less. Like what about 20% of the saturation? Yeah, that's better. That's better. And maybe because of that, in terms of lightness, it has to be kind of desaturated and light. So it's going to be like very, yeah. So not that much. Maybe like 30%. I need some sort of a color picker maybe. Yeah, so I want it to be sort of like grayish like that. Disgusting, dirty fucking sky, mate. Dirty. Yeah, that looks much better, I think. I think that looks much better. So we got some subs. Thank you so much, Billy Sarid, for gifting a sub. Thank you. Really appreciate that. It's a very cool gifting subs and shits. Okay, so yeah, as you can see, it's super easy if you have solid colors. But what if I want the floor to have a texture? Looks like a default skybox color. Yeah, I know. It also feels a little bit like Morrowindish, if you know what I'm talking about. It kind of feels a little bit Morrowindish. I don't know why, but it does. It kind of does. So anyway, so what if you want your floor to be a fucking texture, mate? Fabulous Floor, thank you so much for the subscription, for Twitch Prime subscription with the message. It's Azizin indeed. So yeah, so how do you fucking do the textures and stuff? And what's interesting is that in the article that inspired this entire stuff, let's actually take a look at the article. Let's take a look at the article. So yeah, this one is pretty easy. Nothing particularly special. Yeah, so this is just the texture. So part 2. Yeah, look at that. Like, how do you achieve this kind of shit? Look at that cool scheisse. Look at that cool scheisse. Right, so maybe there are some other examples. I didn't read the second part, by the way, so I have no idea how you do this kind of shit. But I have a couple of ideas, honestly. I have a couple of ideas on how you do that. So essentially, I feel like the way you do that is similarly to ray casting, scanning vertically, but now you're scanning horizontally. Let me show you what I mean. So, so we're. I'm sorry if it was it too loud. I hope it was not too loud. So yeah, I hit the mic. I'm really sorry about that. So all right. It's okay. Okay, thank you so much. So you have some. Maybe I already have a grid, but I mean it's kind of a lame grid. I don't like it. It's okay. I died. Sure, Kappa. So when you have a player, you have this cone. You have this cone that looks like this. It looks like shit, honestly, so let's put it this way. Right, so imagine that you have a separate layer that keeps track of the textures of the tiles. Right, so the texture of the tiles. So essentially, now, you know these sort of like vectors and stuff like that. You can now scan this scene with these lines. Right, you're basically scanning the scene with these lines. And look, so as you scanning the scene with this line, you take a look at the point and that specific line, and look at that point. You are within this texture. You can take the pixel of this thing and you can now remap all of these lines to here. Right, so essentially this line that is super close to the player is the bottom line, the next one, this line, is the next line, and so on and so forth. Like you basically scanning it like that, and you're scanning them in here. And as you're scanning them, you know precisely the color of the pixel that you have to put on that specific line because it's within the cell within the texture. So yeah, this is basically like a scan lines. This is my hypothesis on how to do that. I don't know what's the correct algorithm, and I didn't read the second part. They don't even have any pictures on how to do that. Like in the previous tutorial, they just had some pictures that demonstrated how to do that. Here, they didn't demonstrate shit, which is kind of sad. But this is my first sort of like hypothesis on how to do that. And this is what I want to try. And I might fail, right? So that's totally fine. So if I fail, I may try to read this entire thing just to see how it goes. But I feel like that's a reasonable way to do that. What do you guys think? What do you guys think? I think it's a reasonable way to do. So it's only the problem is that depends on your vertical resolution. You may actually go really, really far. So you kind of need to limit your vertical resolution. So what's your vertical resolution? Right now we don't even have a limit for vertical resolution. It's just like whatever the height of the canvas. Right, but now we'll have to introduce that so we know how far we have to go. So, and this is something that we'll need to do. Sounds plausible. Yeah, I do think so. I also do think so. So yeah, let's make a small break. I'm gonna refill my water and stuff like that. And after the break, I'm going to try to implement this floor and ceiling algorithm. And ceiling algorithm is probably the same. It's just like you do that from opposite direction, right? So we just go towards the middle, right? So makes sense to me? Makes sense to me. Anyways, right. Let's make some break. And okay. So what we need to do? Let's go ahead. Maybe we're gonna even pretend that the entirety of the floor is covered with the same texture. I think that's a good idea. So let's actually see what kind of textures we can have. So this is a very cool pack that I would like to maybe try. So for example, maybe they're too bright, honestly, for whatever we're trying to do in here. But maybe that's totally fine. So there's a wall, grass, and your mom's ass. Sorry. So let me see. So it's gonna be game art. Okay, so we're gonna have credit in here, and let's actually download this entire thing. Okay. So, oh, I should have actually put ampersand at the end. We can't see the progress of the fucking downloading, mate. We won't know when it's finished downloading. So it's 21 fucking megabyte, mate. Okay, so fuck. Okay, I'll have to try that one more time because we don't have any progress. All right, so show me the progress, mate. Okay, so we see some sort of a progress. 20 megabytes is actually quite a decent size. It's quite a decent size. So okay, so let's open it. God fucking damn it, this is not what I want. Yeah, it's a zim bomb. Like, why Windows users do that? Like, why don't you have like a root folder in your things? Like, I don't understand. Okay, so I'm gonna just put this stuff in here, and I'm gonna maybe move this thing in here, and I'm gonna just unzip it. Okay, so that's what we got. Like, I think I know why Windows users do that, because the Windows itself actually automatically creates a folder. Okay, so there's a dirt, grass. It's too realistic, honestly. Ooh. Leaves, panels, paving. Okay, so this, yeah, this is too bright. Planks. Okay. Snow. Stone. Okay, I think I'm gonna take the planks. So let's grab the planks. Let's grab the planks. So index TS. Let's load some stuff. Planks. Wait. Load image data. Load image data. All right, and planks like so. All right. So, and we're gonna catch this stuff. And if we couldn't load this entire stuff, so this is going to become purple. So to test that we loaded it correctly, I'm going to actually use it for walls super quick. Do we have, okay, so we do have this thing, and let's refresh. Okay, so looks like shit, by the way. Looks like scheisse, but maybe that's fine. Maybe that's fine. So there's no anti-aliasing or anything, so it's just kind of weird overall. Yeah, so the fact that I kind of get stuck on the corners, right? So sometimes I get like really stuck on the corners. This is one of the reasons why I think the player has to be circle, right? So you don't kind of stuck in there. Yeah, so that's one thing we need to do. I don't like this texture, honestly. I really don't like it. So rock, sand. Stone wall. Let's use stone wall. Right, so this is going to be like yet another sort of like stone wall in here, but it's a different one, so it is totally fine. Okay, so let's call it just floor in that case. So the name is sort of like the material independent. Okay. Yeah, that looks like, so yeah, now if the floor is this, it's gonna look all right. And it's not gonna be final floor because it's too bright, right? So there's lighting on top of this thing, so it's just, kind of meh. Kind of meh. Oh, and by the way, I just got reminded that we have normal maps for this thing. So I probably need to leave it to do about that. To do, try normal, try lighting with normal maps that come with some of the assets. Right. I think that's an interesting thing to try, honestly. I think that's an interesting thing to try because as we already discovered at the beginning of the stream, so some of the things they do have so they do have normal maps. So they come with normal maps, which is kind of an interesting thing to use for Raycaster. I didn't think people use normal maps for Raycasters. Like, I don't think it's a thing, right? Because the normal maps were invented like way after people stopped doing Raycasting. So it's kind of a funny thing to try. Those are idea for depth, right? These are for lighting. Well, I mean, they kind of like. So the normal maps, how they work. Each pixel of a normal map encodes a vector of a normal. So, and you can use that vector of a normal to sort of compute the lighting on the level of a pixel of the texture, which kind of gives this, a surface like a fake, fake tessellation or something like that. So, I don't know. Right, I'm not really, engine developer, like I don't know the terminology or how to explain that, but whatever. Okay, so I suppose what we need to do, right, so we have a screen width. We also need to introduce the screen height, right, so because we're going to have a limited amount of rows that we're doing, so let's actually go ahead and do that. So we have a screen height. So let's say the screen height is 200. Like, just because I introduced it, obviously it's not going to be used, right? So render scene, right? So we have a render scene, and so yeah, we just use a strip height. So in this one is rather interesting. So right now we're using height of the screen as the canvas height. So what we have to do, we have to now replace it with the screen height, and it's going to fuck up the entirety of the rendering. So screen height. Where is the another CTX canvas height? So this is another place. So I suppose I probably have to maybe replace CTX canvas height with screen height. Right. So yeah, so it's kind of an interesting thing. So it's definitely gonna fuck up like everything. So let me see. Yeah, so it's actually squashed it in a really funny way. Yeah, so it literally squashed it. So one of the things we need to do now is to probably remap this height to something else. So what effectively I'm doing, I'm just like changing the resolution and stuff. And I'm not sure if it's a generally good idea to do it like that. So maybe it is not a good idea. So in here, what I have to do now is I just have to remap the whole thing to the full screen. And like I have to do that on each fill rect and also on each draw image. And it's kind of a pain in the ass, honestly. I really don't want to do that. But I have to. I kind of have to. So in case of a strip width, where do we do this sort of mapping? Yeah, so this is a so that makes sense. So this is a strip width, and this is where we did the whole thing. So and in here I should have just called it strip height, but this is not a strip height. This is another parameter. Alright, so I don't really know how to call this parameter. The strip height is already taken by something else in here. Right, strip height is already taken by something else. But this one is maybe pixel height, right? So because of that, if I'm using this notation, this thing should be also called pixel width and pixel height. So we're rendering with like in a really low resolution, and we're remapping everything into like rectangles and stuff like that. So that's basically what we're doing here. So CTX canvas, you know, height, right? So I take the height and I should divide screen height by that. So and I do a seal in here, which is totally fine. So I want to query replace strip width with pixel width, like so, right? So we do it like that. That's pretty cool. So seal, it's not cell, it's a seal in here. All right, that's pretty poggers, my friend. So in here, so we figured out this kind of stuff, and we just multiply this thing by pixel height. We're just multiplying it by pixel height, and within the here, so the width is one single pixel in here. And these things should also be multiplied by the pixel height. So effectively what we're doing in here is rather interesting. So we're rendering in a different scaling, in a different mapping, which means that we can probably use the context translation and scaling as we do with the rendering in a minimap, so we don't have to do this manual mapping of the things. But I want to do the mapping manually anyway. So then when I introduce the actual context mapping, like with translates and scales and stuff like that, I know that I didn't break anything. Right, so first I want to do that manually, and then I'm going to just use something else later. Anyways, so I'm drawing the image, but I'm drawing the image slightly differently in here. So this is the, in the draw image, the first things are the source. So this is the source, X, Y, width and height, and this one is the destination, right? So this thing is multiplied by pixel width, this one should be multiplied by pixel height, and this one also should be multiplied by pixel height. So I accidentally put a comma in here, so that's totally fine. Are you happy now? So comma should be actually here. All right, so and when I do rect in here, I think it should also be multiplied by pixel height, and this one should be also multiplied by pixel height. All right, so do we have any errors in here? We don't have any errors in here. Okay, let's go. Cool. I actually fixed everything, and the height is, yeah, so now we're rendering with a smaller height, surprisingly, believe it or not. So if I reduce the height to 100, is it going to change much? It actually doesn't change much. Probably, yeah, probably all of that stuff doesn't matter. So what if I say that this thing is like 10? Yeah, let me take a look at the errors. I think I know why visually it doesn't change that much. Because of the fractional parts, right? So the fractional part of the pixels, like, it doesn't really change that much, so it just like looks fine. It kind of looks fine. One of the things to actually bring, like what I was expecting actually is a little bit of a jittering, right? So, but because we kind of take into account the fractional parts and stuff like that, there's no that much jittering, so it's kind of fine. One of the things we can introduce that is by actually flooring the coordinates and stuff like that. Right, so we can actually floor them. So let me try to see. So I think I forgot to acknowledge Fabulous Flow. Oh no, I actually did acknowledge you. So thank you so much for Pushpan. All right, so let me think. So render the scene. Yeah, so this is render the scene. Actually, I think it was render the scene. Yeah. So if I now, so this is just drawing the image. We could just do maybe math floor, right? So this is a math floor, and this one is a math floor. So I want this entire thing act like it's actually rendered with like a low resolution. That's what I'm trying to do, honestly. Though I don't think it's a generally good idea to do it like that. So, and this is width and height. So in case of a width and height, we probably want to actually do seal. Yeah. Seal. So this is a width and height. Okay, so this is just images and rectangle in here. Let's remove the rectangle. So here's the interesting trick, by the way. I'm drawing a semi-transparent rectangle on top of this strip with texture to sort of like shade it, right? I can't modify the shade of the strip of the image directly, right? So I just put something on top of it. Right, so let's not modify this thing, and let me see if it is. Does it feel low res? It feels like nothing changes, honestly. Kind of hard to tell. Right, because now if I put like 50 height, screen height is now 50. Yeah, now that thing fucking changes. Alright, whatever. So let's get rid of that. So none of that matters. None of that matters. Anyways, so why am I doing all of that? I want to have like a limited width to work with. I want to have a limited width to work with, so I kind of know for how far I have to go. How far I have to go. So let me open my paint. So this one is rather interesting. So let me create the grid. So we're still live. Yeah, yes, we're still live. I want to try this floor thingy. I want to try to figure it out. Because it's kind of an interesting problem, honestly. It's kind of an interesting problem. Okay, so here's the player. And the player has this kind of stuff. So as we doing the ray tracing, so one interesting thing is that the height of the strip that we're putting on the screen actually proportional to the height of the screen itself. So essentially, what do we do? So strip height, we take the screen height, and divide it by the distance to the obstacle that we're fucking rendering. So that means if the distance of the obstacle is equal to the screen height, right, and becomes bigger, that means this thing becomes size of a single pixel and less than a single pixel, so it completely disappears, right? So how far you can see actually depends on the height of your screen. So that's basically what it means, I think, right? So that means if the you know, the object is too far away, right, further away than your screen, you won't be able to see it. So that actually means that this entire stuff will disappear as we, yeah, if I just say that the height of the screen is like 5, this entire shit theoretically should disappear after like 5, but it doesn't actually. Right, and I think it's more than 5 cells. That's for sure. We're further away more than 5, so something is incorrect in here. Something is definitely not correct in here. And I'm not really sure why. So if I do the height like 2, right, so this entire stuff should already disappear, but it doesn't, and I don't really understand. Right, so why? Right, because we're clearly dividing this kind of stuff. We're clearly dividing, but it just like doesn't work the way I would expect it to work. So it's almost like this entire thing is ignored. So let me see. Yeah. So this is a strip height, right? So and we just like, yeah. So if this length becomes too far away, it's kind of weird, honestly. It's kind of weird. Yeah, does anybody have any idea why? Right, so this is the distance to the obstacle, and yeah, I don't really understand why it, what if you round it? It doesn't explain anything. This is not what I'm asking. That is instance of RGBA. Okay, so it doesn't matter. So instance of image element, the same thing. The same thing, absolutely the same. So, well, canvas context is scaled, isn't it? So you draw 0,1 thing and it's like 50 pixels. Probably. Maybe. So yeah, because of the scaling. Oh, so that's what you mean about the rounding. Right, so that's what you mean about the rounding. But I tried to round these things and it didn't help. So that means I need to round it again. Okay, so let's give it a try. I see what you mean. So I didn't understand the thing about the rounding at first. I assume that it's a browser cache. I actually do Control-5 every time I, you know, refresh. So that should kill the browser cache. So, and let's also floor these things as well, I suppose. So since it's scaled, yeah. Since it is scaled, okay, so nah, doesn't help whatsoever. Doesn't help whatsoever, so that means I do not fully understand this entire thing. So 200. All right, because I need to know for how far I want to go with this kind of thing. I need to know for how far I need to go. You know what? I'm already streaming for 2.5 hours. I think I'm gonna leave it for tomorrow. All right, so I'm probably gonna do that as a footnote for the session. Right, so it's really hot in here. When it's hot, I can't think. And I already streamed for too long, so I'm obviously getting tired. So let's wrap up. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all on the next recreational programming session with Mr. Zozin. Love you. Yeah. This is the next day, right? So I slept a little bit, so let's continue. So what we need to do, we need to actually finally develop proper floor and ceiling, right? Because right now we have this kind of stupid skybox, but all of that is just like a rectangle and stuff like that. So to do that, I think I need to do a proper mapping of the pixels, or like sort of speak. So originally, so I have a function called render scene. I was trying to do this mapping manually, but I think I should try to start using the translation matrices that come with the canvas rendering context, right? So in CTX, There are some methods like scale and transpose or translate or something like that. Yeah, there we go. So canvas translate. So in here, as you can see, you can rotate the whole thing, and it basically like applies like a matrix transformation, and it just stays like that. And whatever you draw is going to be automatically transformed according to these transformations and everything. So here, as you can see, I'm just taking the strip width, right, and then I keep multiplying this entire strip width to like literally everything. If I scaled something like this, so let's actually try. If I scaled the whole thing with this value, right, with this value, but didn't scale the height, I would never need to even have a strip width and like ever multiply everything by strip width, because that scaling is going to happen automatically for me. Right, let's actually go through the compilation errors. So let me enable the fly check mode that shows the compilation errors. So, and let's go to the next thing. Yeah, as you can see here, I multiply that. The next one is basically 1, right? So I don't have to do that. The next one don't need any multiplication in here. This is going to be 1. This is going to be another one, and this is going to be another one. There we go. So do we have any errors? We don't have any errors. And if I refresh everything, so everything is broken now, right? So I think this is because I have to save and reset the state. Yeah, so here's the interesting thing. So every time I call to scale, it actually scales it more and more and more, right? So we need to save and restore the state of the transformations like we do in a render minimap, right? So if you do save, what it does, it just takes all of the transformations and saves them onto the stack, and then you can restore them, like pop out of the stack. So let's give it a try. So I think I can do the save here, this ctx save, all right, and at the end of this entire stuff we're going to do ctx restore, right, so whatever modifications we do to the context, they're going to be restored. All right, so let's actually refresh this entire thing, and it works. So here's an interesting thing. I just removed the entire concept of strip width, and I don't have to multiply by strip width, and it just works. Right, so I want to do, another thing I want to do is to actually introduce the screen height of some sort, screen height, and scale it vertically in a similar way. Right, so here's the width. So maybe I can do something like, ooh, this one is rather interesting because the ratio of the screen is basically 16 by 9. Yeah, there you go. So this is a 16 by 9, and we explicitly set the width of the canvas to be 60 by 9. So what I'm thinking is that maybe here we could also have 60 by 9, like so, and have some sort of like a screen factor. All right. So I intentionally want the game resolution to be smaller than the size of the canvas to create this sort of like an old school pixelated look, right? So you have a size of a canvas itself, but this is not a real resolution of the game. The real resolution of the game is going to be much smaller. So to create it like in a sort of pixelated way, right? You know what I'm talking about? You know what I'm talking about? I think you guys know what I'm fucking talking about, right? So here, what's going to be the factor? So I think I could like multiply it maybe by 30. Right, I want it to be actually rather small. Yeah, 30 is going to be fine, I think. 30 is going to be fine. So, and in here, do I maybe need to do math floor in case I actually want to do something super small, right? So if I want to do some sort of like a fractional stuff in here, but maybe I'm not going to do fractional stuff like that. Anyways, so yeah, so we have this kind of stuff, and in the render scene, I want to now scale the whole thing. All right, height divided by screen height. This is what I want to do in here. So I suppose it's gonna fuck up. Yeah, it fucked up everything now. And this is because in the implementation of the render scene, we use directly this thing. What we have to do, we have to now replace it with the screen height. Right, so we have to now replace it with the screen height. So I'm gonna replace this thing with the screen height. Right, like so. And boom, so there's quite a few places where we do that. So there's quite a few places where we do that, but hopefully now, yeah, now it is fine. Right, so yeah, so we're mapping everything accordingly, and it looks all right. So if I now make the resolution much smaller, right? So what is if the factor is like 10? So it's going to be super pixelated, I think. Yeah, it is actually super, it works. It actually works exactly as I would expect it. It is not quantized super well. I wouldn't say that it is quantized super well. So I think to make it like properly quantized, we have to do floor and seal on the coordinates and stuff like that. So in here we have x, so x and y, I think we should do something like floor. So that's the floor. Right, so, and in here, math floor, so this is x and y, like so. So this has to be sealing. Like there's no point in doing seal on one, right, but I want to do it for the sake of documentation, for sort of like a symmetry, right? So that means I seal the sizes and I floor the coordinates. Right, you see what I'm talking about? I seal the sizes and I floor the coordinates. There's no reason to seal 1, and there's no reason to seal x because it's actually like quantized by 1. But for the sake of documentation, right, so like, to sort of demonstrate the intent, I still want to do that, right? So I still want to do that. So yeah, I already actually floored this thing in here, but this one is actually the source of the drawing. So the first 4 arguments in here are the coordinates within the image, because it's sort of like a sprite, and the second 4 coordinates are the destination. Right, so in here we don't really do anything in here, so this is where we have to do floor. Right, so this is going to be the floor of this thing, and this is going to be the floor of the another thing. Right, so math seal is going to be that, and this one is going to be math seal as well. And we need to repeat this kind of stuff for the rectangle. So here Emacs just hanged because probably of the LSP or something like that. Right, so here we're drawing an image which is a strip from the texture, and then on top of it we're rendering a semi-transparent rectangle. Right, as you can see, we're setting the fill style with like alpha not being equal to 1, actually less than 1, and this is how we shade it. So this is the texture and this is the shading, right? And the shade, the strip that shades this entire thing is actually has the same size, right? So it has the same size, same coordinates and stuff like that. Right, so maybe because of that, I have to maybe factor out all of these elements. That would actually make sense, believe it or not. But here I'm actually making the strip a little bit bigger, but yeah, let's actually remove extending it so they're the same. So this is going to be math floor, like so, and this one is math seal that, math seal that. So yeah, actually computing this coordinate, because there's the same for draw image and they're the same for the fill rect, and in fact they're the same for this thing in here. We could just pre-compute this strip, the coordinates of this strip, and then just like use them in all of these places, hopefully. So do we have any problems in here? I don't think so. Yeah, now I feel like it is quantized. Yeah, you can clearly kind of see that all of that shit is quantized. I should have actually done this direct scaling in the canvas yesterday. I think I didn't do that because I was a little bit tired, and I was afraid that it's not going to work properly. Yeah, and now everything like feels properly like quantized, like with a low resolution and stuff like that. In fact, we can make the resolution even smaller. How about 5? Right. So look at this resolution. We can keep decreasing resolution. It's just like, yeah. It feels increasingly more and more old school. Yeah, look how jittery it is. The reason why it is jitters like that is because it quantized to the pixel. Okay, so I achieved exactly what I wanted to achieve. This is actually perfect. So what if I make it like actually factor 1? So that means the height of the screen is going to be 9. Holy shit, okay. That is interesting actually. Yeah, so that's a lot. So that means it should fully disappear when the distance from the object reaches 9 or something. Yeah. I think this is, okay, so I would say this is roughly 9 and the whole scene in here actually disappeared. 1, 2, 3, 4, 5, yeah, it's roughly 9. It's also diagonal, so diagonal you need a little bit less of the things. So it is roughly 9, so it works exactly as I would expect it, because, right, as already said yesterday, the way we compute the strip height, we take the screen height and divide it by the distance from the player to the obstacle. So that means as soon as the distance from the obstacle to the player reaches the height of the screen, the object completely disappears in the horizon, according to this math. And I was trying to create a setup where I could fucking confirm that, right? So what if I set the height of the screen to something super small? Will I be able to see that effect of the object completely disappear when I actually reach this sort of distance? I actually reached that. So this is not a reasonable resolution, but if I set the reasonable resolution to even 100, it's kind of difficult to achieve because I'll have to wait for too long to actually go to the distance of 100. So you know what I'm talking about? Right, so obviously we're not going to play with this kind of resolution, right? So, but it's kind of useful to be able to set such a resolution just to test some shit, right? Just to test the understanding of the math and stuff, right? And obviously we're not going to keep it like that. So let's actually make something like 20, right? So let's refresh it one. Yeah, there we go. So something like that is way better, I think. Something like that is way better. Right, and I really like that it is quantized now. In fact, maybe we can get rid of draw image and like draw the pixels ourselves with rectangles and actually sample colors from the textures and stuff like that. I don't know. So we can actually do quite a lot of things. So I saw some subs, by the way. I think I saw some subs. I don't know if I acknowledged them. Thank you so much, Strap Talk, for tier 1 subscription. And Murila Ober, thank you so much for tier 1 with the message. I'm something of a programmer myself. Nice to hear that. I'm really glad that programmers actually watch me because, right, I'm one of these rare streamers who actually makes programmer content for programmers. Not wannabe programmers, but for actual programmers who understand what the fuck is going on. It is really rare these days, I'll tell you, bro. I'll tell you. So, yeah. You know what I hate? I hate that I kind of get stuck when I'm too close to the wall. I kind of hate that. So maybe, like, I want to make the player to sort of slide along, right? Because it doesn't really feel good. Like, I'm pressing forward, and it's just like, I don't know what the fuck is going on. So we'll probably need to do something in here. So I have a couple of ideas. What if we, yeah, so essentially we probably need to do the thing where we try different components of the new position, right? So that's what we have to do. So instead of a new position and even this entire stuff, so let's introduce something like maybe an X. Let's take the player position. So this is a player position X, and we add the velocity X multiplied by delta time. So in here we can check, can player go there? So here is the scene, and then new vector and X, but the old position, right? So it's going to be player position Y, right? And if we can go there, we update the player position to be that. So this is my usual sort of trick. So, and for example, if you can't go in one coordinate, like in X, but can go in Y, you will go in Y, right? So you will sort of like a slide around, so you're not gonna be stuck anymore, hopefully. So we're gonna have an Y. I might as well even copy paste this entire thing because it's kind of like symmetrical code anyway. So this is Y, right? And then here we actually use the X and then NY, and we are reassigning the NY like this. So hopefully that will make it actually slide around. So let me see. Yeah, and finally, so I'm not stuck anymore. Should have done that like earlier. And I don't even need a circle. Yeah, so this feels much better. Holy fuck. Yo, what the fuck? Yeah, I'm just hugging the wall. Look at that. Yeah, just sliding around. Really like that. Really fucking like that, mate. Cool. So maybe we can do committee. So yes. So I think I can actually commit this entire thing separately, right? So yeah, make the player slide along the wall. Right, slide along the wall. I'm going to push that right into the repo. So, and the next thing that we're going to do in here is probably, I don't know, so what we introduce in here? So we introduce like a screen height. Right, let's put it this way. Introduce hard-coded screen height. Right, so that's what we introduced in here. We introduced the hard-coded screen height. So the time has come to try to introduce the floor, right? At least the floor. So as soon as we manage to make the floor, we'll be able to also make the ceiling, because the math is going to be the same, right? It's just like you put it upside down and it works fine, hopefully. We'll see, we'll see. So interestingly, the thing that we're doing here, so this is called render scene. But in reality, what we're rendering, we're actually rendering the walls, right? So this is rendering of the walls. Maybe because of that, I want to actually rename this entire thing. So I'm going to do query replace render scene, render walls, right? Because I'm going to have a separate function for rendering the floor and rendering the ceiling. Right, there we go. So, and I also want to make it separate commit. Render scene, render walls. There we go. Because you kind of have to render them in different order, right? So first you have to render floor and ceiling, and only then you have to render the walls, right? So because you're always gonna, the walls are gonna be effectively always in front of the floor and ceiling, effectively. Okay, so let's go ahead and just straight up introduce render floor. Let's find the render walls, and nearby we're gonna have a render floor. So this is a function render floor. So in here we obviously gonna accept the context and the player position, right? So because the player position is the camera position as well. But scene is rather interesting thing. Scene is rather interesting thing because scene, it's only walls, which makes you think. So should scene also contain floor and ceiling information? Since we actually recently made scene a class, it's sort of like a abstraction nowadays. It's sort of an abstraction. And what's interesting is that it stores the cells, but in fact, in reality, what it does, it stores the walls. I feel like one thing we need to do in here, we need to rename them to walls, right? So this is walls. And in fact, let's actually find everywhere we say cell, right? So here is a cell, heating cell. Do we even use this shit anywhere? I think we do. I think we need to make it part of the scene at some point. Right, okay, so this is the cell. Where are the others? So this thing should be wall, right? And in here we just have walls, right? And this is wall. And now, interestingly, what I can say, I want to introduce a floor, and floor is going to be the texture, right? So for now, I'm going to just set a single texture for the entire floor, right? In the future, we're probably going to have some sort of a map. We're going to say that maybe this style of the floor is going to have one texture, this one is going to have another one, but I don't want to build the data structure for this kind of thing. It's easier for me to just say, okay, so floor is always this texture. Right, so I think it's going to be easier for me to do it like that. And the texture, obviously, we denote the textures with the HTML image element, right? So because that's web, there's nothing much you can do about that. Right, so here's the floor, and this is HTML image element. And here we're going to just save the floor like so. So interesting thing. Okay, so with walls, we need to query replace cells with walls. Boom, we did that. Can you redo that? I don't fucking think so. So here is, we're checking that the point is within the scene, so that makes sense. And then here we get the cell. In fact, we have to get the wall, right? So you can get the wall, right? And you can also quickly check there when something is a wall or not. So this is walls and this is wall. So why it was so important for me to actually rename this kind of thing? Because now you can probably even get a floor by a coordinate. Right, so let me actually say get floor, and you take the coordinate, and it should return you maybe HTML or something like that. what's interesting is that, okay, so here is the thing. Technically, floor can also be RGBA, it can also be image element, or it can be also null, right? In case like there is no floor in there, so you can fall there or something like that. So this kind of thing, I don't even know. So this is not just a wall. This entity can be either wall, it could be either floor, it could be either ceiling. So because of that, I feel like maybe it should still be cell, or maybe we should call it tile. So I think something like tile is a better name for this kind of thing, right? So here is the walls, they are tiles, and here is the floor, it is tile. So that makes sense to me, I think. I think that makes sense to me. So floor here is also tile, and you can, as you can see, a tile can be null, so that means it can be missing and stuff like that. So that's actually pretty cool. So get wall, you either get a tile, and then you can get a floor, right, at that specific position, and you can also get a tile, or you can get undefined. So yeah, interestingly, we can say if you are within the scene, you're gonna return something. If you're outside of the scene, we're gonna return undefined. So then we floor the whole thing, and funny enough, we don't really need this coordinate, so we can simply just return this floor for now, since like you can only set one texture for the floor, we're gonna always return that texture. Okay, so this is a little bit of refactoring that I would like to apply. Obviously the code that was using all the functions is now broken. What we need to do, we need to go to the compilation errors, right? So that's what we need to do. So let's go to the compilation errors. Fly check next error. Okay, so get cell. Let's quickly replace get cells with get wall, because that's what it is, right? So this is a get wall. All right, so next compilation error. So render floor. Okay, so this is not finished yet. So let's actually remove that. What's the next thing? New scene. So it doesn't like something. Yeah, so you have to specify the floor. So what we're gonna set as a floor. Let's set, you know what's funny is that I can always just say null, and it will kind of work. So it tells that by default you don't have a floor. But let's not do that. Let's not do that for now. So let's take, for example, wall 1 and say that this is going to be the floor for now, right? We're going to change it in the future, but it's going to be floor for now. And yeah, we don't have any compilation errors anymore, right? So it's very pleasant to work with the TypeScript, right? So on top of a shitty language, so it really helps you to refactor things, I think. It really helps you to refactor things. Okay, so render floor. So in here, yeah, we accept the player, and we're going to be also accepting the scene because the information about the floor is contained within the scene. So interestingly, so as you can see here, when we are rendering the walls, we're iterating from 0 to the width of the screen. We're scanning from left to the right. We're scanning from left to the right. That's what we're doing. In case of a rendering a floor, what we'll have to do, we'll have to scan from the bottom to the top, actually to the half of the screen. So that's what we have to do. So this is the kind of scanning we're going to be doing. This is the kind of scamming, right? The scam line. So it's not just, you know, in case of a fake 3D, it's not called scan line, it's called scam line. Because it's a fake 3D, right? You know, haha, fun. I'm sorry. Anyways, whatever. So let's implement a scam lining, right? And I suppose, though, by the way, I think in case of rendering the floor and stuff like that and the walls, we also have to save the translation, the scaling, and everything, right? So because we are rendering within the same resolution, right, so to speak. And so yeah, saving and scaling should be done as well in here, right? And here is an interesting thing. So as you can see, here is the render game. Here we're rendering fake floor and skybox, which is just two rectangles at the top and the bottom, right? And in here we render the walls, and then we render minimap. So the order of rendering of these things is super important. So first we have to render the floor. Right, then on top of that we're gonna render the walls, and on top of that we render minimap. Right, so as you can see, we're stacking them on top of each other. So, and in here, obviously, I have to do ctx player scene, right? So I'm passing all this information in here. And in the future, by the way, we're also going to have a ceiling, right? So to be fair, rendering ceiling and floor could be done in any order, right? Because they don't really overlap with each other, so it doesn't really matter. But floor and ceiling should be rendered before walls, because the walls on top of the floor and ceiling. Okay, so what we're going to do in here. So this is the floor. And what we need to do, we need to start iterating backwards, sort of speak. So let me open the Mappaint. So yes, so here is the scene. Here is the scene. Here is the player, and here is FOV. So here are the things. And we also have like a near clipping plane, and this is sort of like a projection. So, and the scan line, the scam line of this thing is actually the bottom row of the pixels. So let's actually imagine something like this. So on the left, we have the top-down view of this scene. So this is like the purple one is the top-down view of the scene. The green one is the actual view of the scene of the player, the actual projection. So this line, right, this first line of the sort of projection thing in here is the bottom line in here. This is the bottom line of pixels in here. So what we need to do, we need to identify this line, and we need to start sampling it with the same interval as we have the pixels here in the width. And as we sample these colors, we put these colors at the bottom sort of line in here. Right, so the next thing we do now, we take the next line along this sort of like rays that denote the field of view, right? And that next line is the second line in here, And we continue iterating this thing. I already explained it on the previous stream, right? We continue iterating this thing, and as you can see, like each row in here corresponds to the next row in here, and we keep doing that until like half of the screen. So we're just going through all of these things, and we're placing them like this, right? So until we go to the middle. So the real question in here, for how long we fucking go in here, right? So like at which point in here we reach half of the screen, right? At which point we reach half of the screen. This will cause distortion, I guess. I don't feel like it will cause distortion, because for distortion we should actually go like arcs. But even if it will go like create distortion, right? So let's implement the distortion and then fix it later. This mindset that I absolutely dislike is that, oh, we should not do that because it will cause problems. No. Let's fucking implement the wrong thing, okay? Don't be scared to implement wrong and incorrect thing, because you will have something wrong and incorrect but fucking working. And then you can fix that. Don't talk yourself away from doing shit just because you can accidentally make it wrong. Fucking fix it then later. It's just like, the thing that works incorrectly is better than the thing that doesn't work or doesn't exist. Right. But if you implement it wrong, think my professor will fail me. Go tell your professor to go fuck themselves. And that will get you expelled from the university, and that will make you a better professional. I'm joking, by the way, don't take it seriously. Right, so, yeah. But there is a part of truth to what I said. Right, so don't actually do that. I'm actually being ironic, but ponder upon the things I've said. So what I'm trying to say is that don't take your professor too seriously, right? So they're a professor for a reason. If they're so fucking smart, why they're not a rock star in the industry, and why they're just a mere professor theorizing about the things instead of making them? maybe this is because they kind of failed at, you know, at the industry and they were kind of forced to go into academia. Like, think about that, right? Just like, give it a couple of minutes of thought. And maybe don't really take whatever the fuck they're saying too seriously. Sometimes they do say important things, but anyways, don't take it too seriously. Yeah, exactly. Modern education is not about intelligence, it's about alignment with the teacher professor. Exactly. It's about alignment with the system. So that's why when you say to your professor, go fuck yourself, while being actually excellent student in terms of like actually finishing the quizzes and tests and stuff like that, you will still be expelled. Because it's not about your skills or your ability, it's about compliance. Just because you said go fuck yourself, you're not compliant with the system, you go fuck yourself. Right, so it's not about like what you can do, not about your skills or anything. It's like a kind of secondary thing. It's a secondary thing. So anyways, we kind of stuck with all that. So yeah, so for how long we're going there? So my hypothesis is basically based on this formula, right? So the object completely disappears. When the distance between the object and the player is the height of the screen. So essentially, we have to go until the height of the screen. Right, so we have to go until the height of the screen. So this is H and this is H. So forgive my writing, I'm using mouse to actually write this kind of thing. I could use a smoother thing. Right, so this is more like width. So this is my hypothesis. So what we're going to be doing, we're going to be just like going this. We can even do a very interesting thing. We can take the distance from the projection plane, add the height of the screen, we can add the height of the screen, and then divide the whole distance by the half of the height of the screen. So basically quantize it according to how it is quantized on the screen, and now we know the amount of steps we have to make in here. So I kind of like this idea, honestly. I kind of like this idea. So maybe it is time for a little bit of a mini-mapping, right? For a little bit of a mini-mapping, because I think this kind of stuff should be visible on a mini-map. The last time in the first episode, right, by the way, this is like a third episode already of the things. So for more episodes, go into the description, there is a playlist in there. In the first episode, I actually started with a mini-map, and I was drawing all of the necessary sort of clues on the mini-map, and that was actually extremely useful. So in here, I'm also need to draw clues, so I think I'm gonna start doing this stuff in the minimap as well. So the problem with the minimap as of right now, is that I can't see field of view because it's literally inside of the square. So if I increase the near clipping plane, if I say that it's maybe like 1, you'll be able to see what I'm talking about. Something is fucked up. I wonder what exactly. Oof. I can't even open. I feel like we went to infinite loop. What the fuck? Wait a second. So expression expect. Okay, so it's 3 5 was 3 5 3. Okay, so let's not do anything in here. Sorry. Okay. Is it compilable? Something really weird happened. I can't even refresh this entire thing. What the fuck? Freaking web! Like, something happened and I can't even control F5 this entire thing. Yeah, it's, of course it's not. Just fucking exit the page. Can you just refresh the cache and try again, please? It went into infinite loop and it just like shitted itself. And now, fucking... I hate web. I hate web. It's so dumb. Alright, so can I just like not do the floor? Right, and now it just cached a wrong version of the page and it's impossible for me to even fucking open DevTools because fuck you. It is so annoying. Like, I hate web. like I can't even open DevTools to invalidate the cache or anything. It's just like, how is that even like a real platform, serious platform for anything? Like, how is that even a thing? Just like, can you stop? Control click. Okay, thank you so much. All right. So that invalidates the cache. So sometimes actually like much more wrong than this. And I'm not even sure what exactly. All right, so let me maybe stash everything in here. And all right, thank you very much, Web. So let's make a small break, because I need to break to deal with this bullshit. Like, it's so dumb. Fucking. Anyways, let's make some break. So okay, I'm back. We invalidated the caches. I'm not fucking closing DevTools, right? So because if I close the DevTools, the invalidation of the cache is gonna go away. Right. So the thing I want to do, I wonder if I can maybe press Control C, or maybe. Yeah, I want to be able to see the entirety of the minimap. So yeah, so here's the thing. I can't see the FOV of the player because it's completely inside of the boundaries of this entire thing. What I want to do in a render minimap, I want to actually stroke rectangle instead of filling it. I wonder if I can do that. So here's the fill style. Yeah, so I can try to stroke the rectangle. So this is a fill style, and this is a stroke style. Right, so this is going to be stroke style, and let's just stroke the rectangle. Right, so let's just stroke the rectangle, and let me see now. Are you happy now? I can't see Scheisse. So this is not how we want to do all of that. So I have a feeling that what we need to do, so since we're stroking, I need to begin the path, right? So it's gonna be CTX begin path, right? Then CTX stroke. It's kind of funny that for fill rect I never really have to do that, but for this kind of thing, no, it feels it completely. So am I doing something incorrectly? Okay, wait a second. What if I comment out this entire thing? What if I comment out this entire thing? What the fuck is going on, bruv? Is it cached again? So disable cache, okay. Why you're not... So this is a rendering of the minimap. This is where we render the player position and stuff like that. What is going on? Am I going crazy again? If I change the color to red, am I modifying the wrong piece of code? Am I modifying the wrong piece of code? I feel like I'm modifying the wrong piece of code and not sure what the fuck is going on. Right, so render minimap. Let's find the render minimap. Okay, what if I don't render the minimap? Okay, so it's using wrong version. It's like I disable the cache, I'm pressing Control F5 to refresh the whole thing. Is TSC running? TSC is running. Okay, maybe something got invalidated or something. All right. Control-Shift-R in the browser. Okay, so... Okay, but Control F5 used to work, actually. Control F5 used to work. I swear to God, like, cache is disabled. Bruh. Okay. Anyways, so render minimap. So I'm trying to do a very basic fucking thing. And it's almost fucking impossible to do that. It's just like... This is what I was trying to do the whole fucking time. It's almost impossible to get it right. So essentially, yeah. So we have FOV, which is entirely within the the boundary of the player, right? So that's what I was trying to do. So I feel like it was a combination of the cache of the browser and maybe TSC watch mode failing or something like that. It was a combination of these things. Or maybe, by the way, it was a caching of HTTP server. But here's an interesting thing. So, oh, I didn't disable it. Okay, wait a second. So I think we need to do something in here. Node bin HTTP server. So I think it's a help. I remember experimenting with this shit, and I kind of like have a false memory of disabling the cache, but then I didn't disable it. Okay, so let's actually add this thing to HTTPS server. Right, so yeah, just in case, I'm also going to disable the cache for HTTP server. I think it's a good thing to do, just in case, because you never fucking know. All right. So that's pretty cool. Okay, so are you good? You Gucci? You Tamaguchi? All right. So and now I want to go to here and render minimap, and within the rendering of the minimap, so this is going to be magenta. Could you please? Okay, so that's working. So this is magenta. Right, magenta. What I need to do, I need to now maybe even increase the size of the minimap. I think this is a good idea. So we have a cell size. What if I make this thing like 10% of the whole thing? So yeah, there we go. To be fair, maybe it's kind of, I'm doing a kind of a dangerous thing because I closed DevTools. But since I can kind of guarantee that the cache is invalidated by Control-Shift-R, maybe it's totally fine. So yeah, I want to have like a bigger minimap. I want to have a bigger minimap. There we go. So here's the bigger minimap because I want to be able to see things. So now, what I want to do, I want to draw a line from the position of the player to the far distance. Right, to the most farthest distance we can see, sort of speak. So render minimap, this is not really render minimap. Let's go to here. So this is just a FOV, but it's actually very super small. We have a line width. To be fair, line width is a little bit too thick for my liking. Right, so let's actually refresh this entire thing. So it's going to be less, yeah, so now it is less thick and we can see FOV like a little bit better, right? So now, what if I stroke a line, but I actually kind of have to stroke a line from the distance from the far clipping plane, right? So I need to find this point. Let me use a different color. I need to find this point, and as far as I know, you can't find this. You can find this point, but it's inside of FOV range, so it's this one. So you take the position, you take the direction, you scale it to, yeah. So this is basically the point. So let's actually grab it. So that's the point where we kind of start. Right, so, and this is not really this is more like a player, right? So you take the player position, you take the player direction, you take it as an angle, you scale it by the near clipping plane, and you add it to the player's position, right? So you add it to the player position. What's interesting is that, so you found this P, and funnily enough, now, so this is going to be sort of like your P1, and you need to find a P2, so let's call it just P1. P1 and P2 is going to be kind of like a similar thing. It's just like from P1 you add the direction angle scaled by the screen height, right? And depending on the screen height, it's just you're gonna see further or nearer. So here we can even take this entire thing and sort of factor it out into the deer, like so. So now we have a deer, and in here we can even draw P1, P2. So we should be now able to see all of that shit, hopefully. Yeah, that's what I'm talking about, by the way. That's what I'm talking about, and it's actually kind of, oof. That is not true, by the way. So what's the height? Height is actually kind of big. But here is the thing. Here's the thing. We don't have to render the floor up until the horizon completely, because we have a far clipping plane anyway. So essentially we're gonna assume that the horizon, the center of the screen, is basically the height of the screen. But we never have to actually go that far, right? Because if we're gonna be inside in an enclosed space, that space is probably not gonna be that huge, right? So you're probably never gonna see the entire horizon. I think that kind of makes sense, right? So, so because of that, I need to use a far clipping plane. So and in here, far clipping plane, there are basically done like so, right? So this is gonna be something like this. So this is a far clipping plane. Yep. So let's refresh this entire stuff. So yeah, there we go. Now we can see that. So as you can see, it's it's kind of funny how it's just like wanders around, but this is like a, yeah, so this is where we have a far clipping plane. This is where we have a far clipping plane. To be fair, for this kind of thing, I would like to have a slightly different color, maybe something like yellowish. All right, something yellowish. So let's give it a try. Yeah, so I want to be able to see this kind of shit. So this is yellowish, and yeah, so we're gonna be just drawing it according to that. Now, I probably want to maybe even have extend the FOV, right? So that's what I want to do. I want to kind of extend the FOV so I can see in its entirety. So I wonder how we're gonna do all of that. So we're probably gonna be doing it in a similar way as we find like P1 and P2. So I don't like the name of P1 and P2. So this is basically near, right? This is the near point of the whole thing, and this is the far point of the whole thing, right? So that's what we have. And in the FOV range, what we're doing is that we take this point, right, and we actually have rot 90. Okay, so I even implemented like a rot 90 to do all of that stuff. So we take a tangent. Yeah, I do remember this formula, right? We take a FOV, right? We take half of that, so near clipping plane, and so on and so forth. But in this specific case, we'll have to use a far clipping plane. Ooh, this one is actually rather interesting. We can basically parameterize that with a clipping plane. Who said we can't fucking do that? Right, so clipping plane, because it's going to be actually reusable now for what we're trying to do now. Right, so this is going to be something like this. Clipping plane. There we go. And now let's go through the compilation errors and stuff. Fly check next error. So this is a near clipping plane, right? So that's pretty cool. And now instead of doing this kind of stuff, I can do const p1 p2 player FOV range far clipping plane, right? So now it is completely abstracted away from here, so which is super nice. So now we are stroking from P1 to P2. In fact, we can just do this entire thing in here, right? So we can even do it like that. So this is a near one, right? So this is the near one, and we have a far one. So this is not the entirety of the errors, I'm pretty sure. So we have to, yeah, so now here we have to have a near clipping plane when we're rendering the walls and everything. And what's the next one? So this is not really an error, right? It's just a warning because we don't use all the things. Okay, so everything is fine in here. And if I try to do that, yeah, now we can see shit. Look at that. So this is sort of like the real FOV that we're going to be probably using for rendering the floors and everything. So this is like a real one. This is the real shit. This is real shit. So that's pretty cool. What's interesting is that when I render minimap, so here is the sort of like a wings of FOV. This is the near one and this is the far one. So we can actually maybe name them near, near, like so. Near, near, and this one is near as well. And this one is going to be far, far, far. Maybe I'm going to just do something like this. Far 1, far 2. I want to factor them out like this. I want to have them both. Right, I want to have them both. The reason why I want to have them both is because I know that I need to iterate linearly from near one to far one. That's what I need to do. I need to linearly iterate from near one to far one. So, which is rather interesting. So, to be fair, I don't even need to do it like that. I don't even need to do it like that. Because what I can do is I can do that in a loop. Who said I can't do that in a loop? Essentially, I can say, okay, so we're iterating starting from plane near clipping plane. So, and then plane is less than near clipping plane plus 10 or something. Plus 10 or something. So maybe plus plane. Plus plane. And so in here, what we can do now, we can just do something like this. So we just do plane, and here I can even rename far to P. Right, so do we want to use yellow? I'm not sure, but let's use yellow. We'll see how it goes. All right, so now if I query replace this entire thing, okay, so it actually goes like 10, which is not entirely what I want. Right, so it is going too far. It is going too far. So what I need to do, I need to figure out, yeah, so if the entirety of the screen, right, if the maximum height you can have is the screen height, and this is the maximum width you can have, you can try to figure out how many sort of pixels per distance you have. It's too hot. It's too fucking hot. My brain does not work. My brain does not work. We need to remap screen. Oh my god, I'm fucking dying. I'm fucking dying. Like I can't think. I can't fucking think because of this stupid fucking heat. Oh my god, it's just so bad. All right. I'm trying to focus. I can't think. Like it's just like I know what I need to do, but I can't understand in which order I have to divide things because my brain is just like jammed because of the heat. So yeah, just a second. I need to grab some more cold water. Just a second. All right. Okay. So I've got some water. Now, what I'm trying to think is that this doesn't look. So that means in here, what kind of steps we have to take in here? What kind of steps we have to take in here? So if this height is, so this is this really like the height of the whole thing. So what's the actual height? Screen height. And if I increase the height, does it affect anything? I don't think so, because we're not taking into account that. So if the screen height render minimap, if the screen height is the same as the maximum, basically the distance in there, you can take half of the okay, I see. This one is really interesting. This one is really interesting because you need to take half of the height and you need to divide it by screen height, which gives you the step with which you have to go, which effectively means you have to actually go not +1, but half. You have to step in half for it to be a proper thing, which makes way more sense, I think. Yeah, so finally it makes way more sense. So that explains it very, very nicely, I think. I think that explains it really, very nicely. So yeah, and after that you sample each individual thing in here accordingly. So now what you can do is you can iterate something like dx, right? So this is dx from 0 to screen width, right, from 0 to screen width, and this is just plus dx, and this is +1 actually. It has to be +1, like so. So, but the way we're going to be doing that, we need to lerp from p1 to p2, and so this is dx. Yeah, it's going to be less in here, so that's very important to remember. And the way we do that is that we take dx divided by screen width, and this is how we're going to be interpolating. So p1 lerp to p2 with this interpolator. Okay, so water helped, by the way. Okay, my brain starts to actually work a little better. Like, what the fuck? Okay, so water, like cold water helped. So I just have like a jug of water in my fridge, just for these kind of situations. Okay, so this is really cool. Fill circle. Alright. So now we provide, so we want to render this kind of position in here. So I'm basically rendering sort of like a samples as we sample all of these things. Okay, so let's give it a try. I'm gonna do something like this, and oof, what the this is a huge fucking, okay, so that's a lot of samples in here. So we probably need to reduce the size. Let's actually make this thing like 5. Yeah, so there's a little bit of a problem here because we can't really represent all of the samples in here, and we probably need to make them very, very small. Very, very small. I don't see scheiße. Where's the render minimap? Yeah, let's go. Like something like this. And I also want to do CTX style fill. Let's actually make them sort of like red. We don't really have to render the samples. I just want to be able to see them. Nothing particularly special. So they're too small now. What about making them a little bit bigger? Fill style. Let's go. Fill. Okay. There we go. That's what I'm talking about. So I just reduced the resolution, and this is basically the samples of the textures that we have to do to render the whole thing. Right, so we're going to be like iterating through each individual sample in here, and we're going to be looking at the position of this point within the cell, right, within the cell, and we're going to sample the pixel out of this thing. You see what I'm doing here? Right, you see what I'm doing? So that's what we're going to be doing. Yeah, and we're going to be drawing a rectangle in this sort of like position. Right, so this is what I'm trying to render in here. And as you can see, here's an interesting thing. This is the same amount of samples, but the closer they are, the more like dense they are, and as they go further away, the more sparse they become. And this is what we basically how we will achieve probably perspective. Hopefully. Hopefully. Interesting. Why are we doing it? Performance? Huh? What? We're trying to implement a floor. What? What has performance to do with a feature? We're implementing a feature. Right? It's such a really weird, like, because we want to have a floor. That's why we're doing that. We're not talking about performance. How can you have performance? Yeah, exactly. Like, I don't understand the question. I'm sorry. Like, I don't want to be asshole. I'm gonna just ignore it. Okay. We're not even talking about performance, right? It's like, why are you implementing operating system? For performance? I'm implementing an operating system. What are you talking about? Thank you so much, Solo Altman, for tier 1 subscription. Thank you. And also, so many subs recently. Did I miss all of them? So Kairosh, thank you so much. No Good Nick, Korai Bear, thank you. So all right. We need to actually start implementing this algorithm here. Should these lines actually be arc? We can make them arcs, but that will, I feel like this will create a fisheye effect. So I feel like it will create a fisheye effect. One of the ways we got rid of the fisheye effect in the scene in here is by essentially turning all of that into the lines, into the straight lines. Anyways, whatever. Let's go ahead and just put that into the render floor. Let's put that into the render floor because this is what we want to do. So render floor, we're going to do it like that. So here's the render floor. And in here, right, so we're starting essentially at the near clipping. And this is only like 10, by the way. This is only like 10. Far clipping plane is actually bigger than that. Oh, far clipping plane is straight up like 10. All right. That's very interesting. Right, so the far clipping plane. Huh. I didn't realize that the far clipping plane is actually way closer than I thought. Maybe let's go back to this entire thing. Render minimap. So let's put this stuff on here because I want to kind of see what if we just use a, you know, this kind of thing. Is it going to make it better? Like closer? Yeah, it's actually pretty much the same, honestly. It's actually pretty much the same. We can even repeat this sort of thing for when it's equal. Right, we can even repeat it for when it's equal. So, but it doesn't really matter. Okay. So now I'm going to go to the render floor. I'm going to go to render floor, and we're just iterating starting from the near clipping plane to the far clipping plane. So we get the wings of this whole thing. We don't need to render them per se. So we're iterating this entire stuff. And so this is a feel and everything. So we need to get the floor at that specific position. This one is rather interesting. So this is the position I'm talking about, right? So this is the P. So this is going to be const P. And I take this scene and I get the floor at P. I get the floor at P. So, and I get either the tile or something else or whatever. So if we need to do this kind of thing, so maybe I'm gonna take floor like so. And for now, if floor is instance of HTML image element blah blah blah, HTML image element blah blah blah. So I need to keep track of the row of the thing. So this has to be something like, can I have several of these things in here, like y? Probably not. And it doesn't really matter that much, so I can probably say near clipping plane, and also I can have something like y. So here I actually call this thing dx. I'm not sure how good of an idea this is, so let's actually call it just x. So this is just x. And y, we're just gonna have it like that. So what I'm thinking in here, so this is a plane, it's less than that thing. And what we're constantly doing, we're actually incrementing y. But what we need to do is more like screen height, but -1. And we're going to be constantly decrementing this entire thing. So that's what we're effectively doing. So we have, now we have x and y and everything. We have x and y. Interestingly, now we need to map. So, and this x and y is exactly x and y on the screen, which is perfect, right? So, which is exactly what I want probably. So now what we need to do, we need to do ctx draw image, right? So this is a ctx draw image, and in here I have to just supply floor, right? So I'm supplying floor and everything. So here I should have the screen. What I have in here, P, I need to take fractional parts of the components of this thing. I need to take fractional parts. How can I do that? Do I have math frac? Probably not. So what I probably have to do, is maybe map this entire thing. So this is going to be x, and in here I can essentially just take x and subtract the floor of x, and that's how I'm going to get the fraction part of the whole thing. So which is going to be super useful. So we get the floor. So right now floor doesn't really matter, but in the future it will. So I want this entire thing to be you know, comfortable to work with. So we're going to say this is the texture coordinates, which is just p and floor like this. And now, so what's going to be the source in here? The source in here is going to be tx multiplied by floor width, right? So it's multiplied by floor width, and we have to do math floor of this entire stuff. So we're taking a single pixel, by the way, right? So then math floor ty floor height, right? So this is x and y. And width and height is going to be 1. We're taking 1 pixel, this entire thing, and this is the source, right? So because the first thing in the draw image is the source and then the destination. In terms of the destination, it's x and y literally. 1, 1. Yeah, that's basically what it is, I think. So we have to put a comma in here. Yeah, that's about it. It's going to be interesting. It's going to be interesting to try. So it's not going to be right to until the horizon. I think it's not going to be right until the horizon, but we don't really need that anyway. So, and by the way, we can even use this distance to color things accordingly, right? So we can use that to color things accordingly. Do I have any errors in here or anything like that? I think everything's fine. I want to go into the render minimap. I'm going to go into the render minimap and maybe get rid of this thing so I don't think it is needed anymore. Right, so maybe I'll also remove that stuff. So what's the size of the minimap? Is the minimap too big? Okay, let's refresh. Okay, so something is happening, which is great. I really like to see that. Well, we can't see shit in this mist. Okay, so let me now increase the resolution. So resolution was around 20, so that was totally fine. All right. So that's very interesting. So this is not even near enough to see shit. I'm actually surprised that it's not enough to see shit. So that's kind of interesting. So the far clipping plane is around 10, so so let me see. So render minimap. So we're saving everything in here. Well, I mean, it doesn't really matter. So render floor. So I'm saving, I'm scaling as usual, and then I'm restoring. So it is very clear to me that we're just not mapping this thing correctly, right? So we're just like not mapping all of that stuff correctly. It's not going too far. All right. So we have to step with much smaller steps in here. That's for sure. That's for sure. It's half of the screen height. Yeah, there's like a lot of steps in here until you can even see that. I feel, okay, so I'm going off of the feeling, but I have a feeling that it's around 25 precisely because the actual height of these things, stripe, is actually like half of this stuff. Right, so it's kind of a bad thing to think about, and it doesn't help whatsoever. Yeah. So, and there is a little bit of fish eye effect. So that means I feel like this approach that I'm taking is not correct at all. Right, this is not correct at all. But it kind of makes sense. It actually makes a lot of sense to do it like that. Right, the way I explained it. But it doesn't work because it doesn't really map it correctly at all. Doesn't really map it correctly at all. But it makes a lot of sense, right? Doesn't it? I think it does. It's just like, yeah. So there's a far clipping plane, but far clipping plane. Yeah. So the problem here is this step, but this step is not helping either. So. Oh, doesn't matter. Okay, so that's the not right way to do that. That's not the right way to do that. So let's take a look at the tutorial then. So in the tutorial, in the second part, they kind of explain it, but they never really show any, what is it called, pictures that would like demonstrate the gist of this idea, right? So they never actually showed, unfortunately. So how it works. Unlike the wall textures, the floor and ceiling texture are horizontal, so they can't be drawn in the same way as the walls with vertical stripes. Instead, they're drawn with horizontal scan lines. We figured that out, actually. The perspective is similar to that of walls, but 90 degrees rotated. But unlike the walls, which used exactly one texture per vertical stripe, multiple floor textures or same one repeatedly may cross our horizontal lines. Understandable, so this is exactly why I decided to do it like that. Drawing the ceiling happens the same way as the drawing the floor, so only the floor is explained here. Okay, also makes sense. I also already figured it out. The floor casting is done before the walls, so the first we draw the entire floor, then over. I also figured it out, right? So pixels as before in the next step. Okay. In short, the floor casting works as following. Work scan line by scan line. For the current scan line, compute the position of the floor matching the left pixel of the scan line and the position matching the right pixel. Okay, wait, what? For the current scan line, compute the position on the floor matching the left pixel of the scan line and the position of the matching right scan line. So this is roughly how I was imagining that, right? So we are scanning from top to bottom. So for each pixel in here, for left and right one, we need to figure out the position. Okay. I lost where, okay. The position and position matching the right. This can be computed as where the ray starting from the camera going through the pixels of the camera plane hits the floor. This can be computed as where the ray starting from the camera going through the pixels of the camera plane hits the floor. I don't understand the sentence, whatever. The formulas and explanations for this are in the forecasting code further below. Okay, I'm not really interested in the code, I'm interested in the idea. We can then linearly interpolate between the leftmost and rightmost point to get the floor coordinates matching other pixels of the scan line. This works because the floor texture is perfectly horizontal. If it were slanted, we would need to do more expensive perspective correct texture mapping instead. I literally did that. Okay, so contributed the idea. Okay, so yeah, this is my idea. I suppose the problem here is that I need to literally do it the same way I do as they explain it, right? So I need to do it literally the same way as they explain it. So I need to work the other way around, right? So my approach, the approach that I take is that I figure out the points on the floor. And then I try to figure out the points on the screen. I think that's my mistake, right? So I think that's my main mistake. I should go the other way around. So I should start from the points on the screen and figure out the points in the space, sort of speak, right? I should figure out the points in the space. So that way should be a little bit easier, right? So that way should be a little bit easier. But before I do that, let's make a small break, right? So I want to refill my water again. Again, it's super hot. It's really difficult for me to think, right? So I need to constantly drink cold water to actually be able to even think at all. So let's make some break. Okay, I'm back. So essentially, what they're suggesting to actually iterate through the each individual pixel of a rectangle, or of the bottom rectangle in there. So that's basically what they're suggesting. But I'm not sure how slow is it going to be, so I'm really curious. Let me try to do the following thing. I'm going to just remove this kind of stuff, and I'm gonna literally just iterate all these things. So it's gonna be x from 0 to screen width, like this. And then I'm gonna iterate let from y, maybe screen height divided by 2, maybe math floor, while y less than screen height. So something like this. And in here, let's say that we're going to fill the rectangle. So I might as well just do ctx fill style, right? And we're gonna fill it with something like red. Just want to see how slow iterating each individual pixel is going to be in here. Alright, so this is going to be x and y, and so this is going to be 1, and that's about it. So is it compilable? It seems to be compilable. So let's go in here, and yeah, it is super fucking slow. Unless maybe we reduce the you know, the resolution a little bit. Or on top of that, by the way, yeah, what we can do in here, when I'm not streaming, by the way, it should be faster. It should be definitely faster. It should be definitely faster. And maybe we can even rewrite some of the parts here in C, right? And work with the pixels directly and stuff like that. So maybe using WebAssembly and everything. Yeah, so implementing all of that stuff in C and WebAssembly would be actually kind of cool, I think. I think it's going to be kind of cool. Yeah. So, all right. So this is reasonable speed, right? So with this kind of parameter, it's slow because of the streaming, but when I'm not streaming, it's going to be faster. Plus, there is a lot of room for performance improvement. It's just the fact that I can you know, iterate this entire like a bottom thing in here, so that's totally fine. Now render floor. So I have an X and Y effectively, right? So I have X. It would be even better to maybe iterate this entire thing like so, right? So iterate it like so. We're iterating it by rows. All right, so within a single row, we are iterating it like that. So the main difficult thing in here, is that how you freaking map the screen coordinates, to the world coordinates. Like, I don't fucking know. So you may say, in terms of the distance, right? So we can always just like map this thing accordingly. So the further away we go, the smaller this entire thing become. The further we go, the smaller this thing become. So this is a half of the screen. The object becomes invisible and shrinks right into the horizon when the distance is the height of the screen. When the distance is the height of the screen, so that means the distance, like if you see the bottom thing in here, what's the distance? What's the distance in here? That's the real question. So if it's a half of that, this stuff, I can't answer this question, because this length is sort of like a percentage, right? Because we're using this length. So the distance is more like, let's say it's h, and this is sort of like a big H, the H of the whole screen. If we divide H over H, so we get the interpolator, right? The interpolator, and that interpolator is interpolated from this to that. So that means this entire thing is literally like the distance of this stuff. So it's more like the actual distance. Like, I can't figure it out. My brain doesn't work. Fucking work. It's so close, but I can't figure it out because it's too fucking hot. Like, I just can't think. Bottom left and bottom right of the screen are the near clipping plane with width and infinity. Thank you so much, Captain. I can't do that. It's too fucking hot. It's too fucking hot, man. It's too fucking hot. It doesn't click. I need to do the render minimap. Bruh, I'm fucking dying. Okay, so everything's fine. We'll figure it out, chat. We'll figure it out. So it's not render minimap. I need a render wall, right? So we're rendering the fucking walls. Okay, so that's cool. It's cool. So what is the strip height? Okay, so that's cool. This is the distance. This is the actual distance, and I don't really like this style, so I took this style out of the tutorial. My favorite style is when I take the distance and sort of like find the interpolator, and then I'm interpolating this entire thing. Right, so this gives me the interpolator, and what's funny is that so the bigger the distance, the smaller this entire thing has to be. So I'm kind of inverting it, right? So yeah, and because of that, it actually worked like this. Okay, so that's pretty cool. That explains some shit. Just a sec. More fucking water. More fucking water. Like I can't. I fucking can't. Somebody fucking kill me. Anyways. So. What do we do? The easiest thing to assume that point that is in here, like that is straight up there, not really here, but straight up there, is the height of the screen. So SH, well, I mean, we called it H in here. So this is the easiest thing to assume. So it's somewhere there. It's somewhere there. Let's render floor. So that's the point there. So that means we need to take the screen height. So this is the maximum length, right? And we divide it by half of the screen height, because it's half of the, like, I'm going through the same idea, right? So through the same idea, but I mean, there's nothing much I can do in there anyway. So when I'm dividing this kind of thing, so that means so this is, you multiplying it by 1 over, so that means you multiplying it by 2 divided by this kind of thing, and then so it's a step 2 per pixel. So it's a step 2 per pixel, so to speak. All right. And we already can do some of that stuff. So and honestly, so when we kind of go into, yeah, that's fine. So, and essentially we can, what was the FOV? Yeah, FOV range. I can take FOV range, which is going to be y multiplied by 2. So this is our FOV range. And who has SO player is FOV range. So we have const P1, P2. So you've got this kind of stuff, FOV range. Okay. Now you can always lerp P2 x over screen height, and that's the point. I feel like I need a smaller resolution texture for it to make sense. We'll probably find something at some point. So this is P, and then I just simply need to find a pixel within this thing. So I'm going to take P map x math floor, and so x minus that, and this is sort of like a texture coordinate in here. All right, so this is the texture coordinate, and now I can try to do the following thing. So I can draw image, right? Draw image. The image I'm going to be drawing is so scene floor, right? So I can actually just take the scene floor, and as far as I know, it doesn't really matter, right? So get floor. Yeah, we can do that. So it's going to be tile. So floor P, right? So we do floor P, and if tile is the instance of HTML this shit. We draw image of the tile. So it's gonna be X, Y. But not really. So it's more so since it's a source, what we have to do, we have to take tile X, multiplied by tile width, of course, math floor, like so. Can you see shit? Math floor, ty, a little bit more water. Okay, tile height, right. So and afterwards, so the destination is actually process forward XY 111. Okay. So I think that might be good. Though I'm not sure if the it has to be 1-1 because we're sampling this entire stuff. So if I did everything correctly, so the performance is going to be roughly the same, and instead we're going to have some sort of a distance. We can even use the distance in here for lighting and whatnot. We can do that, but I mean a little bit later. So everything compiles, right? So where's the compilation thing in here? So let's give it a try. And okay, so I never call render floor, or do I? Oof. So get floor. So it is not contain. Okay. So it's completely outside. Okay, so let's actually always return floor no matter what. Right, so I suppose it just like went completely outside and something really weird happened. Okay, so let's just do that. Yeah, okay, so, and it is kind of slow. And the problem here is that the texture is too fucking big. I think that's the main problem in here. Like, we need a smaller textures. We need smaller textures. How can we make a smaller texture? Like, maybe we can find some of the texture in here, like maybe it's like 32 by 32 or whatever. So they provide some of the textures here. So yeah, these ones, for instance, well, maybe we could use these ones. Copyright ID software. Okay, so let's actually use them. Wolf text zip. Those are 64 by 64. Yeah, our textures are like unreasonable, honestly. So let me see. Yeah. I don't think it's a good idea, honestly. I don't think it's a good idea. So let's actually grab those in here and maybe move them somewhere here. All right. So do they have? Okay. And let's just unzip those things. I personally would maybe rename them to Wolf Tech. Wolf Tech. Barrel, bluestone, eagle. So wood. I really like wood. Now, where's the index TS? We have floors and stuff. So const wood. Await load image data. Assets images. Can you recognize? Okay, it can't see that. Wolf. All right. So let's grab that, put it in here. Wood PNG. Yeah, wood PNG, and we're gonna catch the whole thing. RGBA purple, RGBA purple, shit like that. Okay. So when I'm constructing this stuff, I'm gonna put wood in here. And hopefully that will create something more reasonable. It didn't. It fucking didn't. Man. Alright, that's actually very interesting. Like, it didn't fucking create anything reasonable. So my main problem, I can't figure out how to map screen coordinates to world coordinates, and this tutorial is not helpful in that. This tutorial is not helpful in that. So ray dir for leftmost ray x and rightmost x width. Okay. Well, okay, you figured out ray dir. So current y position compared to the center of the screen, the horizon. Okay, so y. Okay, so this is p. Nah, that's not explaining the main idea. This is not an explanation of the main idea. So that's the problem. It doesn't explain the main idea of the thing. It's just like I implemented it and dumped it into you. Like, no, it's not explaining things. It's not a good explanation, honestly. Can use the texture with a black border and white background as a floor texture to visualize the mapping. It doesn't solve the problem. Alright, so the problem is, how do we fucking map the screen coordinates to the world coordinates? That's the problem. Adding border doesn't solve that problem. Okay, so what do we have in here? Let's just, I'm iterating from here. Honestly, I think I'm doing something weird in here. Yeah, I think I'm straight up doing something weird. So if I essentially start iterating from 0 until the half of the screen, right? So I'm iterating from 0 until the half of the screen, and I would probably should do like dy in that specific case then, right? So in here we're just incrementing this kind of stuff. So this is going to be dy. So, and what I have to do, I have to take the near clipping plane, and I have to keep adding. Yeah, I have a feeling that I have to keep adding this kind of thing. So near clipping plane, like a half of that. So this is what I keep adding in there. So because it just gives you the distance, but also I need to figure out the actual y. I need to figure out the actual y, which is basically like a screen height -1 minus dy, and this is like the actual thing in here. I think that's what we have to do, roughly. Okay. It didn't fucking help. It didn't fucking help. It simply creates noise. It simply creates noise. And nothing else. Just the noise. And it's not even... Yeah, man. I don't know. I don't know. Like, I'm doing exactly as this tutorial says. What am I missing in this logic? What am I missing? Like, the problem is probably with like how I determine the distance. This is where the problem is, and I can't see that. Reverse the formula from the world to screen. This is literally what we did. Yes. Did you just join? I think you just joined. Okay. I don't know. I don't know, man. I don't know. So, is the mapping near far to 0 screen height? Not really. It's actually half of the height. Thing is, my brain actually blows up a little bit because because I'm thinking not in correct terms, not incorrect terms. So we have like a super near thing, right, which is like a near clipping plane, right? So this is a near clipping plane, and a super far thing, which is basically screen height, right? So that's the distance. So to figure out the price over row of height of the pixel, we have to take half of the screen. So we take in a half of the screen. So this, maybe multiply by 5. And So we have to take the far minus near, so this entire sort of distance, and divide it by sort of that. I think that's the step that we have to do. Right, that's basically the step. And maybe I can even save it as a step. And that's the step I have to use in here. So that's the feeling I have, right? That's the feeling I have, but I'm not 100% sure. So it could be... Yeah. So... yeah, let's give it a try. And I'm not sure if I'm using the right version, honestly. Like I constantly need to make sure that this is not. But parentheses around... Yeah, thank you so much. I need to make sure that there's no caching involved or anything like that. Nope, that doesn't help. That straight up doesn't help. It feels like it's just sampling garbage. Like, why is it sampling garbage? It's sampling within the same thing, which is fine. Okay, that's totally fine. But it ends up sampling garbage. Like, it's just like it doesn't... you can't make sense of that. Maybe the mapping here is not correct. Why are you explaining me shit? Like, I should not get angry at people who just explain me shit instead of trying to understand the actual problem that I'm dealing with. So there's some sort of a bug or misunderstanding of the problem, and I need to understand what exactly. Isn't the clipping plane in the game coordinates and a screen height in a screen coordinate? Yes. Try to see an image that is easier to see what's happened on, like color each quadrant with different color. Maybe that's a good idea. So that's okay. So let's give it a try, I suppose. So here is that. So this is that and that and that. So near clipping plane. So that will require changing, like maybe how the floor works and everything, but that's fine. That's totally fine. So okay, let me. So this is fp, and the way we can do that, x plus fpy, right? So we can just do mod 2 equal to 0, and yeah, this is a good idea actually. This is a good idea. Thank you so much. So if that, we can just return new RGB. Like, is that a good idea to have new RGB every time? Yeah. So color 1, right? So it's going to be RGBA. Color 2. So this color 1 RGBA red, RGBA blue. Okay. And this color 1 color 2. All right. So, and then when I do get floor, get rid of that. Okay. Doesn't work. Because we never actually handled this shit. Yeah, that explains it. So else if tile instance of color RGBA, actually we're going to be doing ctx fill rect, and what we have to do is actually ctx fill style. We take tile to style. Yeah, I think it's to style. And we're going to be using the same sort of coordinates, actually, x, y, 1, 1. Right, so that's what we're going to be doing. All right. So yeah, there's a little bit of fucky-wucky here going on, that's for sure. Thank you so much for suggesting that. So it's obviously not fucking correct. It is so fucking obvious that it's not correct. All right. So I'm really happy to see that. I'm actually really happy to see that. So yeah. It's actually rather interesting how it is like that. So I'm doing mapping from P1 to P2, and I get the floor, and funnily enough, yeah, I'm just flooring this thing. Yeah, this is not fucking correct whatsoever. We don't even need this kind of thing, so it's part of that stuff. So, yeah, what's the actual step? What if the step is 1? What if the step is 1? I don't think it's, yeah. So, let's use only one near clipping plane as the first thing. Right, it's always blue. Sometimes it's just, yeah, that makes sense. And so what's funny is that now I'm saying, okay, this is going to be one thing in here. This is going to be one thing in here. Yeah, so this is 1. So, and that kind of makes sense. Okay, so that kind of makes sense. Maybe, by the way, the problem here is that we kind of moving forward way too fast. Right, so what if I like reduce the step with which we're moving forward? It's going to be super small step. So what about, it's about figuring out that step. Yeah, it's about figuring out this specific step. What if I say that it's like 25? Now we're fucking talking. Yeah. That's what I'm talking about. So it's something about this step. So if it has to be like kind of small, it's smaller than I thought initially. And you look, yeah, there is a fisheye effect, right? So there is some sort of a fisheye effect in here, which is kind of cool. All right, so this is kind of close. So that means, yeah, it is trippy actually. It is super trippy. Now, what I can do is maybe switch to the floor. So I think I'm gonna do the following thing. If true, we're gonna simply return this floor. Otherwise, we're gonna be returning something else in here. Right, so now we should be able to see. We can kind of see the floor, but it's really warped. It's really warped. So if I switch to this one, okay. And I don't really understand why there is a fisheye effect, honestly, because because it's basically working with like a straight lines. We're working only with the straight lines. See what I'm talking about? It's just only straight lines. So I understand fisheye effect in case of the walls, because we're sort of like shooting a rays in sort of like a arc. It's sort of like arc, but it's not. So it's kind of interesting. So maybe we can. The straight line is shorter than the closer to the plane. The straight line is shorter when it's closer to the. This is a good point, actually. This is a good point. That's probably why. So and the way, okay, so we can actually. This is very cool because we can try to now do the ray. Like we can shoot a fan of arrays. We can shoot a fan of rays. And just interpolate them as we go. So that's one of the things we can do effectively. All right. Is that a good idea? Honestly, I don't know. Could be rather interesting, but it's actually taking too much time. So, floor. So the thing that kind of bothers me is that in the tutorial they say, oh, just like interpolate the lines and stuff. Don't worry about it, bro. Just interpolate the lines. We can try to read the tutorial one more time. It would be way better, honestly, if they just made a drawing similar to how they did in the first part. So, because in the first part, I just figured out majority of the things just by looking at the drawing, right? So stuff like that, right? So that was very helpful. Yeah, that was insanely helpful. Things like that. So, and then I don't even have to read the rest of this stuff. And here, they don't really explain much. They're just like, don't worry about it, just interpolate something. Don't worry about, here's the source code. So it's just, it's even funny a little bit if you think about it. So, okay, so the floor casting works as follows. Work scanline by scanline. Okay, for the current scanline, compute the position of the floor matching the left pixel of the scanline and the position matching the right pixel. Fair enough. This can be computed as where the ray starts from the camera going through the pixel of the camera plane hits the floor. This can be computed as where the ray starting from the camera going through that pixel of the camera plane hits the floor. Oh, okay, so they're already thinking in third dimension. All right. So, okay, that actually could be, I think. Right, so that's something that we could do. I think. So now this is from this side. So you can think of this like Z. So this is the Z axis and this is Y axis, so to speak. Right, and we're looking at the center. So that means we need to think about the height of the player as sort of like 1. All right, and depending on FOV, right, so we're gonna be, yeah, I suppose, okay, so that's probably what they're doing here. Okay, that explains the whole thing. So what do you mean he's the floor? I think they mean that you literally have to do the same thing as with the walls, but now 90 degrees down. So yeah, I thought that we're gonna only do like a 2D math, right, on X and Z, but now I suppose we rotate it, right, and now we sort of kind of shooting down. Okay, I see what they do. Okay. So, and what they're saying essentially is that you only need to do that for 2 sides, left and right, and then later you can just interpolate it with a single line. So yeah. Yeah, that makes sense, I suppose. But that is actually way more time than I expected. It's actually way more time. So, well, I don't know, like it's already 3rd hour. Do I want to do that? Do I want to do that, especially with such a hot weather? I don't know, probably not. But I mean, I guess I learned something. So this is something that I'll have to do. Yeah. All right. Okay, so I guess that's it for today. I'll think how to organize this episode, honestly, because it's really hot. Like, have you noticed that when it's hot, it takes me so much time to get to something working? It's just like, it's so difficult for me to think. It's just like, it's insane. All right. So it's like doing the floor and the ceiling is just like takes too much time. I don't want to like post 5 hours video to YouTube. Nobody's gonna fucking watch that. So yeah. All right. Let's see how we can do that. That's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on next recreation programming session with Mr. Zuzin. Love you. Mwah. Okay, this is the 3rd day, and I slept a little bit yet again, right? And I thought about how we can finally draw the floor, and I came up with a couple of ideas. So first of all, so if you try to actually simulate the projection, the 3D projection of the floor onto the screen, right? So we can imagine that this is the player and this is the eye of the player. And this is the screen, right? So this is the screen, and essentially this is sort of like the view, the field of view in here. And also we can think about this thing as a floor. So this is a floor, and we're looking at the player from the side, right? We're looking at the player from the side. So you can probably say that this is a, you can't see that, but this is a z-axis. And this one is more like y-axis, right? So this is y. So let me actually pick a different thing in here. So this is y-axis. So if you split the screen into discrete pixels, right? If you're splitting it into discrete pixels like so, you're gonna end up with something interesting. I think we want to actually pick, you know, finer intervals so we can fit more pixels in here, right? So it makes sense to do that up until the middle point. The middle point is where kind of things break, right? But if you don't do the middle point, so let's actually start shooting rays into the floor, right? From the eye into the floor. So, okay, so this is the first ray, and this is where we have to sample the texture of the floor. So now, if we shoot another ray through another row of pixels, we're gonna end up a little bit further, like so. We're gonna end up a little bit further. Let me actually draw it in here. And now let's shoot another ray through this screen. It ends up somewhere here. So here here's another sample, and so on and so forth. You can already notice something interesting, chat. You can already notice something interesting, and that something interesting is that every time I go up pixels, I actually shoot further and further and further. And that probably explains the situation that we had yesterday, because I was sampling at the equal intervals, right? I was sampling at the equal intervals, but if you actually try to simulate the 3D projection of the floor onto the screen, you're gonna end up with something completely different. Right, so you're gonna end up with something completely different. And this is sort of like the sequence that grows over time. So I don't know if I can... Yeah, so it's now even further. I don't really know what it is. It feels like something quadratic, right? But that's what you end up with anyway. That's what you end up with anyway. So that's pretty cool. If you have, let's imagine that we're currently sampling maybe like this one, like we're trying to figure out the position of this thing. So let me actually put it like this. And we kind of know the angle, like specifically this angle, right? So we kind of know specifically this angle, and this angle is more like alpha angle. I wonder if I can actually bring my tablet. Maybe with the tablet it's going to be a little bit easier. Okay, so my tablet works these days. Today, I mean. Okay, so we kind of know this angle, and we kind of know this value, right? Let's actually call this value A, and that is the value of the height of the player. Right, that's the value of the height of the player. So this length, like the hypotenuse of this entire thing, is C, and this one, let's call it B. So by knowing A and alpha, we can already kind of figure out C, but I think more importantly for us is going to be B, because it's going to be basically a distance from the position of the player towards the point. You can't see shit, right? So towards the point, right, that we have to sample, right? Towards the point that we have to sample. And we already kind of used that formula before, but actually rotated, right? So from a different plane in one of the previous episodes of raycasting. So essentially, if you take a like tangent of the of alpha, I wonder if I can actually have a little bit better handwriting. Yeah, thank you so much for improving my handwriting. So tangent of alpha, what effectively you're getting the opposing side of the triangle divided by the adjacent one. So opposing one is going to be B over A, right? So you have B over A. So since you know A, you can actually quite easily multiply this thing by A, right? Both of the sides, you multiply them by A. The A cancels out, and you end up with just B. So this is how you find B. So as soon as you know this alpha angle, you can quite easily find B, and that's the distance. And since you know this point, you can already finally sample the precise texture on the floor. So it sounds easy enough, Sounds easy enough, but it's not that easy, right? So this triangle is actually not as two-dimensional as you would think. It's actually in 3D. You need to take a look at this entire thing now from the top, right? You need to look at it from the top. So let's go ahead and do that. So this is now the screen, right? So this is now the screen. And this is where the eye is, right? And this is field of view. It doesn't really matter what exactly it is. And maybe I can show the coordinates, right? So if this was Z, right, now Z kind of goes towards in here, right? So Z goes there. And this one, so if this was Y, this is more like X, right? So this is more like X. So this specific triangle, so you look forward, and that specific triangle is actually not here. It is not here. It is slightly at the angle. In fact, it is right on the edge of the field of view. So maybe I'm going to actually make it a little bit, thicker so you can see that. So this exact triangle is at some sort of an angle, and we can call that angle something like, for example, beta, but we don't really care what it is, honestly. We don't really care what it is. So the way we kind of sample this entire stuff is rather interesting, right? So we can imagine that we have a screen, right? We can imagine that we have a screen like so. And we're sort of looking, so this is the eye, and we're looking at the screen, like right at the screen. And yeah, here we're just iterating pixels of the, like a lower bottom. And these points in here are one of these pixels. So we're constantly sort of like shooting rays to all of these pixels, right? And in here, as you can see, this specific triangle is going to be at an angle. But at that angle, we can kind of figure out only, let's say, this length, right? We can kind of figure out this length. So since it's on C, we can say that this length is something like C prime, right? So it's shorter than an actual C. And since we can also kind of figure out sort of like this distance, right? This distance, and more like this distance, yeah. So we can say that this one is A prime, and this is going to be B prime. We can only figure out sort of this triangle, right? You see what I'm talking about? See what I'm talking about? So, but what's funny is that from this kind of thing, you see that B prime over alpha prime is equal to the tangent of alpha, right? So if you take these two things, you divide by another, you get a tangent of alpha. But tangent of alpha is also equal to bigger B divided by bigger A. So that means you can essentially now take B prime over A prime and multiply it by the bigger A, and you get exactly that B. Right. So, and that's basically the formula that we have to use to find this sort of distance that we have in here, right? This exact distance, and then knowing the direction, we can actually shoot the vector in that specific direction until we reach the point on the floor. And once we have the point on the floor, we can sample it. If it's a texture, we can take the color of the texture. If it's just a color, we can color it in a specific way, and we can finally color this specific pixel, right? So what is interesting is that this formula is extremely simple, but the justification for this formula, right, you have to like really think in 3D, right? You really need to think in 3D, right? So, but hopefully that makes sense. So we'll see how we can implement that, but I think it's kind of interesting, right? So it's a little bit of trigonometry, but you really have to think about it in 3D space. And the tutorial that we're constantly working with, how do you get alpha prime? Well, you know your position in here, you know the coordinates of the pixel that you are shooting the ray into. So you have 2 points of the vector, you find the distance between those 2 points, and here is your alpha prime. So, no, not alpha, but a prime. So does it make sense? Because that's what it is, right? So because you trust, like, you know the coordinates, the 3D coordinates of this thing, you know the 3D coordinates of this thing. How can you find the distance between them? You just, like, you know, Pythagorean theorem, right? So you just sum of squares and square root, and you got it. So, and then you can quite easily get the rest. Well, I mean, so it's actually alpha prime, but, like, I mean, you know all of these points, just do the math, right? How do you explain that? Right, so there's, like, not that many unknown things in here. All right, so that's basically the idea. I haven't tried this idea, so I just came up with this math right before the stream on a paper. Right, so I don't know if this is the right solution to do things. I don't know if it's the right solution to do things. So, but this one is actually kind of complicated. It's a little bit complicated, but if we manage to figure it out, I think it's going to be kind of poggers. So another question that I have in here, what is the height of the player? Right, so we have this value, but what is exactly the height of the player? So considering that, we determine the height of the wall based on the distance, right? And we essentially say that distance to the wall is divided by the height of the screen. We can literally say that the height of the player is half of the height of the screen. Right, that's what it is. Like, the height of the player is half of the height of the screen. Yeah, so half of the height of the screen. So this is kind of obvious. That's what it is. So yeah, I think we basically have everything. I think we have everything. So we should probably try actually coding that. Let's go ahead and do that, meine Freunde, meine Freunde. Okay, so where is the rendering of the game? Rendering of the game. So let me see. So this is a render game, render walls, render minimap. Okay, cool. So we need to have a render floor. So CTX player scene. All right. So, and again, I have no idea if it will work. I don't know if whatever solution I just described in here is the right solution. Right, so this is kind of the solution that was insinuated by the tutorial, but the tutorial is so obtuse, I can't fucking understand it, so I don't know for sure if it is the right solution. Right, so it's gonna be a surprise. Maybe today's stream is gonna be yet another failure, but I mean, there's no failures because we're just gathering information. On the previous stream, we actually did a first attempt. Right, a first attempt, and we learned that this is not the correct way to do that, so which was actually kind of cool. So we gathered some information. So okay, so here's the render, the floor. This is so cool. Imagine it being wrong. Get fucking damn it. Thank you for the motivation. Thank you for the motivation today. Anyways, yep. So what we need to do? We need to just, like, start iterating the pixels, right? So we need to start iterating the pixels. For let x equal to standard for 0. So I think I'm going to be iterating the rows first, right? So we're going to be iterating the rows. And what's interesting is that we don't really need to do this math for each individual pixel. We only need to do that for these sort of pairs of pixels on the side, because then as soon as we find where they hit the floor, we can in a space just linearly interpolate from first point to the second point. So that's pretty much it. And interestingly, maybe we can even do that for literally just one point. So we can figure out the distance from, like, the position of the player. So this is sort of the position of the player to that point. And then we can replicate the same distance to the right point and then just linearly interpolate from one to another. So we don't even need to do that for two ends. We just need to do that from one end, and we can kind of mirror it. So this is actually kind of cool. We can actually kind of mirror it. So yeah, okay. So let me see. Because of that, we're going to be iterating the rows, right? So it's going to be a row-wise situation. So from 0 to, I don't know, so it's not going to be probably from 0, but more like from the half of the screen divided by 2. But we don't really want to go into the middle point, if you know what I'm talking about. So I probably want to do something like +1 just in case. Right, so, and in here is going to be screen height plus y. So there we go, we've got these kind of things. And yeah, there we go. So what's the 3D position of the player? So we know the player position here, and it's X and Y, but it's X and Y on a plane of the scene. Oh, this is really interesting. I said that Z goes in here, but in the game engine, Z is actually upwards. Right, I didn't think about that. So I was thinking about Z in terms of like OpenGL coordinates. Right, because of that, like X and Y coordinates in the player position in here are actually like X is the sideways and Y is forward and Z is actually upwards. Right, so yeah, so we know the position and the Z, right, so we can even maybe destructurize this entire thing. So I'm going to say Px, the player X, is the player position X, Py of the player is going to be player position Y, and Pz is going to be half of the screen, right? So like this, because we're looking right at the center. We're looking right in the center. So this is like sort of like a 3D coordinates of the eyes of the player. I think that makes sense, because this kind of thing will be useful to find the distance from the eye to the pixel that we're talking about, right? Distance from the eye to the pixel, right? So this is the half of the screen. You can literally see this is a half of the screen. Here's my eye, and I find the distance from my eye to one of the pixels on the screen. Look at the camera. Look at the camera, right? So imagine that the camera is actually like this is the bottom. Can I actually line it right? So this is the bottom, right? And we're sort of looking at the triangle at the bottom. So here's my eye, and I find the distance from the eye to one of the pixels on your screen, right? So I'm looking at one of the pixels on your screen. Anyways, whatever. So what do we have in here? So what's the coordinates of that pixel? That's the real question, honestly. What's the coordinates of the pixel? So it's more like, yeah, third eye. Yeah, this is a third eye. So it's more like an X. So we can say this is a screen Y. This is a screen Y. This is the row, and the actual screen X is going to be 0. So it's basically the leftmost pixel in there. So it's that one. It's that one. But how can we find the pixel on the screen? That's the real question in here. So this is 2D coordinates on the screen, but then if we put that screen into the 3D space, what's the 3D coordinates of the pixel in that 3D space? What's that? That's the real question in here. And in fact, maybe we can easily figure that out, because we kind of know the, you know, the, how to say that, where the screen is located within the space, right? So in a player, we have a FOV range, right? So here's the FOV range, and it gives you 2 points in here, which are rather interesting. So it gives you P1 and P2, right? So it's a very important and interesting function, honestly. So let me show you what it means. So imagine that we're looking at the player top, you know, from the top. So we're looking at the player from the top, and the player has a certain sort of FOV, right? The screen is in here. The screen is in here. And this point is called P1, and this one is called P2, like this. So, and this is the screen in the 3D space. And these 2 points are 2D points. They just show you the range of like where the screen is located in the 3D space. So, and if you have a player, you can just query, okay, so what is your FOV range? Right, FOV range, it's basically from P1 to P2. So, which is kind of cool. So that means that since Sx is equal to 0, right, so it's basically P1. So that thing, in terms of like this 3D space, is located at P1. So we can easily say, right, we can easily say that Sx is P1x and Sy is P1y. So that means this one, again, has to be Z, right? All that has to be Z. Right. So, and since the height of the player, the height of this screen is the height of the screen, we can just use that as this. Huh. Chat, that is very interesting. We view the coordinates of the screen as with y going down, but the z in the game space actually goes up. So that means in here, to get the actual sort of z, so let me actually call it something like z. So sz is going to be the opposite one. So it's going to be something like a screen height minus z, also minus 1 or something. Okay. I think I figured all of these things out. I think I did. So this is the 3D coordinates of the player's eye. These are 3D coordinates of the pixel that we're currently looking at. Do you understand what the fuck is going on? Do you understand what the fuck is going on? So yeah. So that means I can now do the following shit. I can do like maybe dx, right? So dx is going to be sx minus px, all right? And let's actually repeat that for y. So x, y, boom. And then I'm going to replace a y with z, boom. So we have dx, dy, dz. So then we can take squares of all of these motherfuckers. We're taking the squares of all these motherfuckers, and we are taking a square root. Math square root. And you know what we just found? You know what we just found? We found C prime. That's what we just found, like literally. So here is the 3D coordinate of the eye, the 3D coordinate of the pixel, but we only found it for like the left side. But it doesn't really matter because like once we find B, you can use it at the length for sort of this side, for this direction. So you can mirror this entire thing. So you can simply mirror this entire stuff. So it doesn't really matter. So yeah, that's pretty cool. So this is C prime, so I'm gonna call it CP. It stands for C prime, okay? All right, so CP, and what is, do we even need CP? I don't think we need CP, honestly. Yeah, because we're using B prime and A prime, so we don't need that shit. Since we don't need that shit, like I probably don't need to even compute dx, dy, dz, right? So fuck that. So, but what is effectively A prime? So we're going to say AP. So what is AP? AP is basically SZ, right? So it's basically SZ. So this is that. Because it's sort of like, it's not really a length, right? So it's more like SZ minus player Z. Right, so this, since it's a z coordinate, so we take the biggest one. It actually goes up, so that means it has to be the player one minus sz. But it doesn't matter, you can always do absolute, but I think the player one is going to be that. Anyway, so this is the length that we have in here. So B is rather interesting. B is the one that is going to be slightly like rotated. So that means we actually still need to do the you know, Pythagorean theorem, but slightly differently. We can actually do that on the into D rather than 3D. We don't have to do that in 3D. We can just do that into D. So how can we do that? So this is PZ. So we can do PX, PY, right? So this is basically PX, PY. I can just take the new vector px py, and I don't even have to do that because new vector 2 px py is just a player position, right? It's just a player position. So this is the first one. And the second one that I kind of need to subtract from, actually I need to subtract that thing from the thing that I'm gonna just say. It's the screen, I suppose it's a screen X and screen Y, right? So it's a new vector Sx and Sy, which we don't even need because it's just P1, as you can see. So Sx and Sy is just like P1, right? So we are subtracting P1 from this one, and that gives us the length, right? So this is the length, and that is basically AB, right? That is basically AB. Pretty cool. So not AB, but BP, right? So it's a B prime. So now the formula is B prime over A prime, B prime over A prime, multiplied by actual A, which is the height of the player, right? So which is PZ. And that gives us the length, the actual B. And that's it, honestly. So we basically found the length. What we need to do, we need to take P1, subtract player position, normalize it, right? So it's just 1, and scale it to B. And we found the first sort of leg from which we have to start interpolating. So I don't really know how to call this kind of thing, so but I'm gonna call it like T1, right? So this is gonna be T1. And the second one is going to be T2, but it's basically the same, but from P2 to player position, and we scale it by B. There we go. So now, we are iterating X, right? So we are iterating X from 0 to screen width, right? From 0 to screen width, something like this. And we are interpolating T, so basically T1 lerp into T2 with X over screen width. There we go. T is the coordinate on the floor. This is the most important thing in here. It is the coordinate on the floor. This is actually kind of cool, believe it or not. This is actually kind of cool. So I think that's the whole formula in here. That's the whole formula. So we don't really need Sx in here, right? So this is that, and Cz is basically an inversion of this entire stuff. So it's really easy to lose yourself with within these computations, but I mean, yeah, that's raycasting for you. That's essentially raycasting. So anyway, what are we going to be doing in here? We need to basically get the scene and get the floor at T, right? So we're getting the floor at T, and it gives us the color as of right now. So if I understand correctly, right? So it gives us the color. So this is going to be basically the tile, right? So this is the tile, and if tile is instance of, if the tile is instance of RGBA, something like this. So RGBA, now we don't even, yeah, we don't really even need to look into the coordinates, right? So we only need specific coordinates if we want to do the texture sampling, right? So we don't support texture right now, so it's totally fine. So we can just use T as a color. Now we need to figure out the position of the pixel on the screen, right? So let me see. So we already know X, which is totally fine. Z, we can use Z as Y, right? So because the actual Z within the space is inverted or like stuff like that. Since it's inverted, I think I'm gonna call it Y, right? So this is gonna be just Y, right? And because of that, this is Y. Okay, cool. So it's going to be draw, maybe CTX fill rect. So this is going to be fill rect. And how are we going to be doing all of that? So we need to scale this entire stuff to the screen scale. Right, we need to scale it to the screen scale. So let's actually put this thing in here. And at the end of this entire thing, we're going to do CTX restore. Right, so we're going to be doing CTX restore. So afterwards, what do we do? So we have to do X, Y, right? So this is X, Y, and 1, 1. But on top of that, we have to set fill style. Is it fill style? Why are you hanging? Okay, so tile to style. All right. I think I got it. I think I got it. The funniest thing in here is that you don't need that stuff as well. Right, so you don't really need that stuff as well. Okay, so this is VP, then you do that. All right, so that's pretty cool. So what's the size of the whole thing? So it's probably 20. Okay, so it compiles, right? So it seems to be compiling. So what I did is just like translated this entire like math to code, right? So I don't know if it's going to work. So maybe it's actually like a bad idea to do it like that. All right, that's very interesting. It's doing something, but it's actually super. It's super slow, but it's something. Huh. All right, that's very interesting. It kind of works, but I think there is a little bit of the problem in here. So first of all, let me maybe reduce the size of the screen, right? So because I think the size is first try, almost first try, but it doesn't work exactly as I want, but the perspective seems to be correct. The perspective seems to be correct. Right, okay. So, yeah, so it doesn't feel, okay, so it feels static, but in terms of rotation, it looks correct. Right, something wrong with how we sample this entire shit. So let's actually do render floor and let's see what is going on here. So it seems to be like standing, which is kind of bizarre to me, right? So it doesn't change the position. Oh, I see what is going on. I see. We have to be adding then player position. Yeah, so player position, position add, right? So this is a player position add, and this is a player position add. Maybe you can get rid of the like player position adding or something, but I mean, that's totally fine. So are you recompilable? Okay, so that seems to be fine. Okay. Yeah. So that feels out of sync with actual walls, as you can see. That is, it is correct, don't get me wrong, but it's completely out of sync with whatever we have in here. All right, you see what I'm talking about? But I mean, it's already better than we had before, than whatever we had before. That's already much better. Like, it feels like a legit thing now. Also, yeah, I didn't do anything with the middle line. I wonder if what if I just include the middle line? Will it work? It's moving against you. Yeah, it's kind of weird. Well, I mean, no, it's actually moving correctly, I think. Yeah. So essentially, if you take the walls and you disable the walls, if you simply disable the walls, it looks all right. Right. So it's just like the cells don't match the actual walls. The ant simulator, yeah, that's probably what it is. The cells don't match the actual walls, and I kind of wonder why. Is that because of the height of the player? Right, is that because of the height of the player? I don't really know. So what if I say that the height of the player is actually screen high? But I mean, it's not based on anything, right? It's based on just like a feel. No, it's actually not. Okay, so but what if I divide it by 4? Nah, it has to be half. It has to be half. Right, okay, so I don't really know like what exactly is going on here and why is it like that. But let me actually see. I don't think there are any problems in here in the get floored situation, right? Because we just floor the particular point, right? So we hit the floor with a particular point, and we just floor it, and that means we effectively get the coordinates of this entire thing. right, and then we just sum up x and y, and depending on whether it's even or odd, we just give you the color, and that's about it. So why the walls themselves would not fit the tile map? The floor is matching the tiling in the minimap. The floor is, you think it is matching the tiling in the minimap? Is it? I don't actually think so. I don't actually think so. So the, oh, you mean the walls actually match in the minimap, but the floor doesn't match the minimap. So there is a clear discrepancy in here. And I wish I knew why. I really wish I knew why. So let me maybe think a little bit about that. We're just iterating. It does look like it matches minima, but the floor tiles are bigger. Maybe it's the wall that don't match the minimap. Maybe that's the problem. No, it actually doesn't look like that. Is it off half a cell? I honestly don't know. I honestly don't know. There's like minus is missing somewhere. All right, so let's maybe make a small break. We're already having like a better progress today, right? So this is already better than whatever we had yesterday. So yeah, they're just like so fucking big, honestly. I don't think they have to be this big. That is true. The red blue squares should be size of the wall. Yeah, so they should be a size of the wall. They feel too big. They do in fact feel too big, and I don't really know why. Right, so like what's up with them being this fucking huge? Yeah, it's sort of like a double the size. All right, anyway, so let's make a small break, and after the break we're gonna try to figure out. So I need to pour myself a little bit more water. Okay, so one idea that I had is that when we're rendering the walls, we also added a little bit of like an anti-fisheye hack. And I feel like that maybe that anti-fisheye hack actually sort of makes the floor and the wall be incompatible. Right, so to confirm or deny that, I think what we should do, we should bring that hack back. So the way we do that, so this is the distance that we're talking about, and this is the distance from the obstacle to the projection plane. From the obstacle to the projection plane, but not to the eye of the player. So what we have to do the full living thing. Oh my god. So I need to take the point where we hit the obstacle, and I have to subtract that from the player position, and I have to take the length of this entire thing. And that should bring back the fisheye effect, hopefully. So does it compile? It seems to be compiling, so I'm going to go back into this thing, and let me actually refresh. And no fisheye effect. What the fuck? Where is the... Oh, okay. Ooh, this is so cool. I brought back the fisheye effect, so you can clearly see that there is a little bit of a fisheye effect. You can clearly see that. But the floor is not matching still. The floor is not matching still. So at least this is something. So is it clear that there is a fisheye effect? I think we can actually go maybe around here. Yeah, you can clearly see the fisheye effect. Though it's not really that big of a fisheye effect. I don't know why I was trying to get rid of that. Yeah, it actually kind of looks cool, honestly. It kind of looks cool. Huh. I really like that. Look at that. Yeah. Yeah, floor move fast. Yeah, I know that. I know that. So I brought back the fisheye effect specifically just to see that. Oh, we can get rid of the floor for now, just to see how cool it looks without the floor. Yeah, there we go. It actually works faster. Yo, why did I get rid of that? It actually looks super cool. I mean, it's okay. It's a little bit nauseating. Yeah, so if it were like a long corridor, I think I would start vomiting by looking at it for too long. Right, this is not a particularly good idea. So, where is the render of the walls? Okay, let's bring back this stuff. Okay. Yeah, one more time. Yeah, much better. No fisheye effect. No fisheye effect. Pretty poggers, meine Freunde. You can see the limits of the cube. Thanks to the textures before the plane course, it was far worse. Honestly, true. I think maybe that's the case actually here. Maybe that's the case. Render floor. Let's bring back rendering of the floor, and the rendering of the floor does something weird. So rendering of the floor is just like, yeah. What? Maybe it just goes too fucking far. Wait a fucking second. When in all honesty, I never actually took into account the like a near clipping plane, but I never had to because I have just this this point in here, right? I just have this point in here. Also, what if I interpolate them in a different order? Maybe that's the problem. No, I don't think so. I'm already guessing this point. Like if you start guessing, that's a bad sign, right? So you should not be doing that. Guessing is kind of bad, honestly. Okay, so yeah, we have P1, and this is the player position. All right. So BP. So we take P1, we subtract player position, and we take the length of this entire stuff, and that's basically that B in here that we got, right? So that's basically that B in here. Okay. And what is A? A is... SZ. So I think maybe something with SZ, honestly. Because we're doing the Y, and coordinates Y go from 0 to height, but the Z in our case goes from like 0 in here to the height. So we kind of like invert this entire thing, right? So, and that's why this is the size Z coordinate. And the A is this thing minus this thing, which is obviously going to be smaller. So make a long corridor and the invisible portal at the end. We haven't finished making an engine. So I feel like there is a problem with A somewhere here. That's what I feel. That's what I feel about this entire stuff. There's a problem with A. I don't see any problems in here. So this is X and Y. Everything should be fine. We go from here to here, and yeah. Okay, so the only potential problem is somewhere here. The only potential problem is somewhere here. So let me see. So if I'm iterating, so it's going to be half. If it becomes bigger. Nah, I don't see any problems. Man, I don't even know how to debug this shit. Console log. Yeah, maybe we should start doing console log. On top of that, maybe I can try to just debug that like literally in a console, right? So let's actually have some sort of like a test TS, right? Where I'm going to simply move the screen width and height, right? So this is a screen width and height. Right, so do we have test? Does it automatically? So it already compiled test, so I can try to do console log screen width, screen height, screen width, screen height, and then I can do node test JS. Okay, so that makes sense. So in here, when I do render floor, I can start iterating Y, right? So we're basically iterating Y, and let's just do console log Y, just to see, like in terms of Y of the screen, right? So where are we iterating the whole thing? Right, so I'm going to try to run it. Yeah. So starting from 45 up until 89, and the height of the screen is that. So looks good to me, honestly. I don't see any problems in here. So this is width, and this is height, and everything is all right. So let me try to do that. Okay, so that's pretty cool. So then what I do, I actually transform that into Z, and Z is actually starts from the bottom as 0 and goes up. Right, so if I do SZ, right, so yeah, and it's, well, I mean, we're iterating it from the bigger one, but it doesn't really matter, right? So just what's important is that for that one, it's just that. So for the player, then we take the PZ, which is the Z position of the player, right? So this is a Z position of the player, and A is the difference between these two things, right? So, and we can do AP, right? So, and it ends up being basically the same, right? It doesn't matter. Or maybe, wait a second, maybe it didn't recompile. Yeah, it didn't recompile properly. So it's just like initial like difference of A, right? It's this thing. It's this one, right? It's this one. So, and then we do BP, which is the, yeah, So what's funny is that that just means that we never have to, yeah, we never have to recompute it in here. So we can kind of pre-compute this entire thing. If this is like how we do that, we can just pre-compute this thing. Right, then we divide BP, B by P, so it's an opposing one, and this is a tangent. So then we can multiply it by PZ, which is the whole thing, which will extend it and give us the bigger B, by which we can now scale the rest of the stuff. I don't see the problem. So I debugged something similar annoying to debug by rendering the numerical values on the screen itself rather than console login or similar. Sure, but I mean, even as I console log these things, they don't really explain to me what the fuck is going on. So yeah, so the wall seems to be like half of that, but I probably need to divide something by half. But what exactly? Like, I don't fucking know what exactly I have to divide in it by half. It doesn't make any sense. So far, like, it feels like I made a mistake somewhere, but I double checked everything and I don't see a mistake anywhere. Shouldn't be BP multiplied by cosine of beta. Why? Why should it be multiplied by cosine of beta? This is a good, okay, so you caught my attention actually. This is something interesting. Right. Why should it be multiplied? Because we just need its length. We know the height of it, and the height is here, and the beta is just like, it doesn't really matter, honestly. Like, it doesn't be. Is the floor supposed to move? Yes. Why does it have to be cosine of beta? It doesn't make sense. I can multiply it by the cosine of beta, and cosine of beta, by the way, is half of the FOV. Cosine of beta, FOV, half of that, but I don't think it's going to solve anything. Wait, nothing changed. Did it recompile? Okay. So something about the test index. Just a second. So fly check. What's that? Cannot it's because of the test. Okay, so let me remove this entire stuff. Verify now. Okay. Yeah, it doesn't change anything. So it doesn't really change anything. So do you have a redefinition? Okay, so everything's fine. Render floor. No, I don't think it has to be that. I don't think it has to be that. What am I missing? What am I missing in this thing? Can you make the player higher when rendering the floor? It feels like you're closer to the floor than the render. This is a cool idea. Okay, so what if the player height is actually the full screen height? What if it's that? What if it's actually that? I think this could be it. Your illustration assumes the screen is touching the floor. Yeah. So you mean something like this? So what it assumes that it's touching the screen? Is it something bad to touch the screen? I don't understand the implication of that phrase. What's up with that phrase? Okay, it is touching the floor, so what? Easiest way to... okay, whatever. So... but because, like, it just makes sense that this is the height. I feel like if I'm gonna be making the player higher, that means I have to redo all of the computations in here. I think P1 sub position is always perpendicular to the camera, not pointing down the... I know, that's the point. That's kind of the point, because that thing is B. So, yeah, that thing is like here. We computed this length, and that's why it is perpendicular, because that's what we want. That's what we want. Yeah. What's interesting is that the logic is correct. The logic is fully correct, otherwise we wouldn't see a correct floor. The floor is correct. That's the thing. The floor is fully correct. It's just it doesn't match the thing. So something with the scaling doesn't work. So AP multiplied by 2. That's an interesting idea. We can give it a try. Okay, so let's multiply by 2. So did it recompile? I don't know if it's recompiled. It's like, I hate web. What about half? Alright, so... Did it recompile? I don't fucking know if it recompiled or not. Okay, so none of that helped. Okay, so it doesn't... Why? Did it recompile or not? Or is it cached again? Man, I hate web. So, did you cache? Like, I'm doing Control-Shift-R, Control-Shift, like, fucking uncache already. Dude, oh my god. I also changed the... Okay, so... Right. How people, like, enjoy programming in this platform? Like, I don't understand. Because you can never fucking know. You can never fucking know. So everything is... yeah, everything is correct in here, but I mean... I genuinely don't see the problem. What if I do P2 in here? I don't think it's there. I know that I can disable the cache in the console. It doesn't work if the console is not opened. That's the dumbest thing about web tools, is that for the cache to be disabled, dev consoles has to be opened. As soon as you close them, that tick that you put in there stops working. And you do have to do Control-Shift-R and shit like that. Like I don't understand, like, people who suggest, oh, you can actually disable it in dev console. Do you guys know how dev console works? Like, people who suggest that, do you guys know how it fucking works? Okay, it's just like, don't understand why you're suggesting it then. All right. So if it's something about FOV, and dock the console, that's a good idea actually. Maybe I should do that. Maybe I should do that. You know what? What if I try to do that on a level of a minimap? Let's go into the minimap. I think I've got an idea. Like, so the problem with this kind of stuff is that how do I even fucking debug that? Right? Because I don't see a flow in the logic. Right, so because there's two layers in here. There's first mathematical logic in here, and there's a second layer, implementational logic. I checked the mathematical logic, I don't see any flows. Okay, I checked implementational logic, I don't see any flow. Okay, now what? Right, so like how do you even fucking debug that? Because like you debug that when you know that, for example, logic is correct, but the program is doing something incorrect, and you can work out the discrepancy in here, right? So, but I didn't see flows in the logic, right? So it's just like everything should be correct, right? So it's kind of bizarre. One thing we can try to do, we can try to render all of that stuff on the level of a minimap, right? So just to see if it kind of like works out the way that we expect it to work out or something. Okay, so the minimap is a little bit bigger now, so which is good. Okay, so let's go into the floor, maybe the render floor, and yeah, let's go. So render minimap. Okay, so rendering the minimap. So this is a player, magenta, and shit like that. Okay, that's cool. Okay, so maybe I can try to do something like this. So as we rendering this entire stuff, so what we can do is just fill circle CTX in here. So when I'm filling the circle, I'm actually using T as a center, and the other thing is that we specify the radius. So let's actually say that this is going to be the radius. Maybe it has to be something like super small. So, and maybe we're going to be doing only like the first iteration. Right. Can I have two lets in here? So if I can say let I0. I can't even have several lets in here because it's... Okay, apparently I can. So let's say 2 plus plus I. I said I, comma, actually N. Alright, so, okay, you can actually do it. So you're telling me that I can do shit like that? Okay, I didn't know that. Alright, I'll know that. That's pretty cool. So we have only one row, right? So we have only one row. And let's see if we can now do something about that. Okay, so this is actually too many rows. Alright, so we can kind of see all of these things. So this is how they go. That explains it. That's a little bit too far, honestly. Right, that's a little bit too far. And if we... Yeah, honestly, that's like really fucking far. What's up with that? So if I change the FOV to a little bit narrower, how is it going to change this entire thing? Oof. So if I change the near clipping plane to like 5 to half, because I want to be able to see. Are you working it? Alright. Oh, I feel like I didn't properly compile shit. Yeah. God damn it. So if V is a have, it's going too far. It is going too far. It is going too far. So we can already clearly see that. So render minimap. I still think the P1 and P sub should be different. You're not. This is not a helpful message. You're just distracting me to tell me non-helpful message. Please stop doing that. Don't abuse my trust to you, just to tell me just like some useless message. Don't do that, please. All right. Okay. Now I need to recollect my thought again. Because I got knocked off by a useless message. Okay. So yeah. If we understand this kind of stuff correctly, so we have these two things. We have A and B. If we divide B by A, that is, B is an opposing to the angle, right? So it is opposing to the angle divided by A, which is adjacent, right? So and the tangent of that is alpha. The tangent is going to be a relationship between a bigger B, right? Between a bigger B and that thing. So yeah. I feel like it just scaled up too fucking much. What if we kind of assume that the height of the... I have a strange idea, honestly. The height of the player is half or 0.5. So this is the height of the player. And when we're doing Z, right, so okay, we're doing this kind of stuff, but then we're just dividing that by screen height. We're just dividing it by screen height. So what if the size of the screen is just like literally 1, right? So, and the size of the player is like half. Is it going to do anything? Maybe it's wrong to think it this way, but I don't fucking know. Did it recompile? Does it do anything? It still goes too far. Like dude, I don't fucking know. Did it recompile? Alright, so I need to dock out the thing. Please. So yeah, separate window. So it didn't really change anything, so that's fine. Didn't really change anything. So it still goes too goddamn far. It still goes too goddamn far. Why would it be? Damn, what's the problem here? Like, what's the fucking problem here? Like, all right, so I can clearly see. I can clearly see that it just goes too far. That means maybe this kind of thing is just like too big. Maybe that's what's going on. It still goes too far. Like, I don't know if it like I'm refreshing it correctly. So what screen row? I'm not showing any screen rows on the minimap. Though, wait. You got, okay, so I see what you mean. Let's actually, yeah, you're right. I see. Okay. So that's a good point. All right. I think there is a potential in here. Okay. So let's Can I disable this code by just doing false? I think I can. Now I'm gonna bring that code back into the render floor. If it works, it's gonna be kind of bad because I have no idea why it works. So this is gonna be this. So now we're basically assuming that the size of the screen is kind of like 1. So tile, and we need to do scene get floor t. Are we gonna work? Or gonna? So this has to be tile, yeah, of course. Okay, so the compiler seems to be compiling. So I wanna take the render minimap and let's move it to like 3. I wonder, does DevTool caching work, like disabling caching work, if DevTool is out of the focus? Right? I wonder if it does. Okay, I disabled render the floor. Okay. Nah, it doesn't work. It's still too big. What am I missing? It's something super dumb, like I swear to God, because like, can you parentheses? I don't think it matters, honestly, because usually these kind of operations like division and multiplication, they evaluate it from left to right. So somebody suggests to do this kind of thing, so to do the other way around. I don't think that's how it works. Yeah, it doesn't matter. So I have to make some improvements. Mine is also slow fact, so it seems to be performing way better because I have a lower resolution. I actually intentionally did it in lower resolution. Have you tried the square screen theory? Okay, so let's give it a try. So I'm gonna actually do 9 by 9. Right. No. Well, I mean, okay, so there is like 2 layers to that. There is an actual shape of the canvas element, right? The actual shape of the canvas element and the resolution of rendering, right? So they are not necessarily matching. Let's put it this way. They're not necessarily matching. Right, so square screen doesn't work. What else? Does anybody have any other ideas? Right, so there was an idea with something player sub X, and somebody said that, okay, you have to do something different here, but what exactly? What exactly different I have to do in here? It's not helpful, so should I not normalize it? I don't know, it's not particularly helpful to say that, oh, you should do something different. What exactly different I have to do here? So I don't actually think so. Maybe, okay, so what if I, well, I mean, AP2, but didn't I already try AP2? People, do you watch the stream? Do you watch the stream? Didn't I already try AP2? It literally didn't help, unless I just don't refresh it properly. Try multiply, but like I literally just tried. What are you guys talking about? There you go, this is multiplied by 2. So so I just multiplied by 2. So you I just did whatever you suggested. So all right, I like, why would it not work? Okay, so let's try to see maybe tutorial yet again. So the problem with this tutorial, maybe you're missing -1 somewhere since the floor is moving the wrong way. How is it moving the wrong way? It just moves faster. No. How is it moving? Like, no, it's not moving the wrong way. What are you talking about? Am I missing something? If I remove the walls, and if you just look at that without the walls. That looks correct to me. Like, where do you say that the floor is moving incorrectly? Like, it looks correct to me if you just remove the walls. It's just like, it's fine. It's just the walls are like not matching. Right. It's just like not matching. Optical illusion. Yeah, maybe. Is it already? Man, like, I enabled the walls. Please recompile. Swear to God, web technologies. Your point of view is too close to the wall somehow. Maybe that's what's going on. Ah, man, I hate this. So this is a screen height. The half of the screen height. This thing is that. I'm so disappointed. I'm so fucking close. I'm so fucking close, and I don't understand why it is not working. I don't understand why it is not working. It's just like, what if the screen's... No, it's not. Whatever. BPAP, what is wrong with this shit? By the way, having DevTools here doesn't fucking work. It's not helpful. Oh yeah, let's go. Oh shit. Yeah. So what if it's half of the PZ here? Are you... Okay, so we obviously kind of extending this thing. All right, so this one, the more we multiply this thing, okay. All right, so the, what if I just do that? What if I do 4? What if I do 8? This PZ is not big enough, apparently. And what is PZ? It's the distance. It is not big enough, apparently. Interesting. This is actually interesting. So that means this, I was right, this value is not correct. It is just like not correct at all. Fascinating. Right, so we found the tangent, like the tangent of this thing, and then we can kind of try to extend this entire stuff. So I already know. So obviously I want to try to go through this logic one more time. Like so. Right, and all right, so we have this sort of like distance, right, and we're trying to find some sort of a point in here, right? Sure, we're trying to find some sort of point in here. This is alpha, right? So this is A, which is the full height. This is the full C, and actually this is C and this is B. B is like the full length in here up until this point, and this point is what we're interested in. Right, so this point is what we're interested in. So, and the tangent tangent of alpha is the opposing one, which is b over a, right? So that makes sense, that nobody will disagree with that. But then if we take a look from the side, we take a look at that shit from the side. So we take a look at that shit from the side. We're usually like grabbing one of these sides in here, and this side is P1, right? So this side is P1 and this side is P2. So the distance from the player's position, right? So PP player's position and P1 is actually this thing, right? You can say that it's a B prime. So this distance in here, can I just do that like this? This distance in here is a B prime. So P1 and PP, right? It's that distance in here. Pretty cool. So A prime, which is like a smaller, you can actually kind of compute that very easily. It's just like depends on the current distance in here. Right, so it's just like PZ. So, and now if I do B prime over A prime, I get tangent of this thing. And essentially now I need to somehow multiply that by the full height in here. By the full height in here, and this is A, and we decided the height is half of the screen. But maybe, what if it's a full screen? Well, I mean, we tried 2. That didn't help, right? So if I just do screen height, that is not going to work. Yeah, that is not going to work. So what about 2 screens? 2 screens. Also doesn't work. So yeah, it has to be something like around 10. It has to be like around 10. And even then, it is not fully correct. Wait, it is kind of, yeah, so it's not aligned with the edges and shit, unfortunately. Wait, what the fuck? So 10 is literally just aligned. It is fully aligned actually perfectly. Why is it 10? Can anybody explain me? Why is it 10? Far clipping plane. Far clipping plane is not really used that much anywhere. If I change the far clipping plane to 12, it is not changing anything. Yeah, it's not. It has nothing to do with the far clipping plane. So, all right. So we figured it out. Screen factor is 10. Oh shit. Wait a fucking second. Screen factor. And now screen factor is 20. No. But now look. Screen factor. Why 10? Where is the fucking... It's not a screen factor, I just changed it. Where's the screen factor, like 10 coming from? Far clipping plane doesn't matter, I can put 20 in here. 1 over near clipping... Maybe, okay, just a second. Right, so I just want to put the resolution where it's bearable at least. So I changed the clipping plane to this. Did it actually refresh? Okay. So well, I mean, we probably can just divide it. All right, can anybody explain me why? Why do you have to divide this thing by the near clipping plane? You cast to the plane, not the screen. Maybe. I mean, we got it. We fucking got it. I don't understand why. Like, why do we divide it by this? So that means like, that means I don't understand. But I'm glad that we figured it out, nonetheless. Normalizing, that's why you divide by one Veiler. I don't know what is a Veiler. Value, you mean? I don't know what is a Veiler. It has something to do with the normalization, yeah. It has something to do with the normalization. But that is fucking bizarre. Anyway, so just a second. Can I now accept the floor value somewhere here? So we're gonna just accept floor as a HTML image element. So this is going to be the floor. HTML, this floor. Okay, new scene, and this is going to be wall 1. All right, so yeah, okay. So what you don't like in here, this thing has to be HTML image element. All right, so and is not assignable to parameter HTML and well, I mean, whatever, dude, whatever. So this has to be tiled then, and this thing has to be tiled, sure, whatever. And then in get floor, we just always return this floor. So next fly check next error. Okay, next one. So we don't even need this shit anymore. I mean, this one is not a thing anymore. Fly check next. Can I just ignore it somehow? Anyways, so render floor, else if tile instance of HTML image, blah blah blah. Draw image. We're drawing the tile, right? We're drawing the tile, and then so what do we have in here? X and Y, but it's actually, yeah, so we have to take the T and we have to floor it. So this is going to be math floor, right? So we do math floor, so it's called C or whatever, doesn't matter. CX multiplied by tile width, CY multiplied by tile height. We probably want to floor all of them. Math floor, like so. Then is B prime is just a 1 over clipping plane? I don't know. I don't think so actually. Though could be. So clipping plane is just like a distance, but at the same time, I don't know. I don't know what is going on, honestly. Like I'm trying to comprehend like what the fuck is going on, but I can't because I'm too dumb for this shit. Okay, so so this is the source, and the destination is XY111. Yeah, that's what we have. X1Y11. Okay, so does it compile? It seems to be compiling, so let's take a look at it. Okay, bruh. So it's not. So when I do this thing, I return like. Did it recompile, or am I having like a cached phantom version yet again? Bruh. Please uncache. Please. Why don't you just return? Bruh, I don't fucking know. Is it like not rendering anything, or am I? Okay, so if I just return color1, are you gonna be working? Yes, you are working, but then I return your floor. Are you working? You're not working. You don't want to use the floor. So I pass the floor to, okay, new scene. So I just do that. Do I not initialize the floor, by the way? No, I do initialize the floor. So instance of HTML image element, right? So it's HTML image elements. Yeah, and I just draw. Am I going fucking crazy? I feel like I'm going fucking crazy. So first 4 parameters is the source on the image. So here's the source on the image, and then the destination, and that should work. Where did I make a mistake? Is it? Why don't you work, bruh? Oh. What the fuck is going on, honestly? So get floor. Okay, so it's well, I mean, it should always return you the tile no matter what, right? So it just returns you a tile no matter what. We pass the tile. Bruh, like, do I have to refresh everything completely? Like, bruh, what the fuck? Okay, maybe there is an error in the console. Like, I don't see any error in here. Eastern egg from the engine. Where is the error? Where is the error? Like, I literally don't fucking see it. It's the worst thing ever, honestly. Because, okay, so here's that. I passed the wall. Maybe take just fraction. Yeah, probably something with a fractional part. Just a second, thank you. Render floor. See, no, this is the. For fuck's sake. Okay. I'm already tired, as you can see. Fractional part. Yeah. So that explains. That explains. Okay. Well, that kind of works. So the we probably want to actually load something like wood, and we did have wood in the assets. We did have wood in assets and wolf tags. By the way, it's not really open game R, but I mean whatever. So we have mossy wood. Yeah. Assets. Let's put it this way. What's that? So it's gonna be const wood. Oh wait. Load image data. Okay. Wood PNG, and of course catch RGBA purple, something like this. So this is wood, and there we go. Please refresh. Please refresh, motherfucker. Did I put the wood in here? No, I didn't. Okay. All right. So that seems to be the case. No, that's all right. That's all right. Yeah? It's so fucking slow, bruh. Yeah, and this is also because I'm streaming and shit. Alright, so we can reduce the resolution, of course. Let's actually say the factor is 5. The factor is 5, so it's much better now. So, but there's a little bit of a floor. And yeah, we're kind of working. We're kind of working. So what if we increase the FOV? What if the FOV is going to be much bigger? 75. Oof. 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 That is... yeah. That was bad. So let's not do that ever again. For clipping plane. Oh, by the way, so I actually need to bring it a little bit closer. Yeah. So, and screen factor. Yeah, screen factor, please. Okay. Yeah, for the textures, it's a little bit too slow. Right, for the textures, it's a bit too slow. So, yeah. But we figured it out. We figured it out. So let's go back to the get floor. Right, when it was something different, right? So const p map math floor, right? Math floor tx plus ty, right? So this is gonna be mod equals 0, right? And this is gonna be color 1 and color 2. That's what we're gonna be doing. Refresh. So with the colors, it's a little bit easier, right? With the textures, it's a little bit harder. Do you figure out why 10? Because it's a near clipping plane. It's a inverse of a near clipping plane. I still haven't figured out why exactly we have to do that. But it is what it is. It's actually kind of interesting. Near clipping plane. So yeah, that is interesting, honestly. That is really interesting that we have to do it like that. Yeah. So if we rearrange scales by near clipping plane, that doesn't tell me anything. It's baked in if we rearrange. Nothing of that tells me anything. I need to understand the logic of this entire stuff. I need to go to the formulas like carefully, and then I can say that I understand that. But it's kind of cool that we figured it out. Finally, we have floor. So it's obviously slow, but that's fine. We can make it faster later, right? And we can try to figure out different ways to make it faster. Like, I think the easiest way would be to just like rewrite it in C and work on a level of individual pixels, because right now we're doing something super fucking stupid. Like, for example, drop image, right? Drop image. So yeah, this is the stupidest thing I've ever like written. Because here we're just like cutting out a single pixel out of the image, like we're using this image as a sprite just to put a single pixel. This is like honestly dumb. All of that should be done like on a level of like a low level and shuffling bits and bytes and stuff like that, and it should generate like a pixel map that then should be like swapped onto, like bleeded onto the canvas. That's the right way to do that to make it fast. So, and maybe in one of the future episodes, we're going to be actually rewriting this entire thing in C, right? So maybe we're going to be rewriting all that stuff in C. So for now, by the way, maybe I'm going to change the colors a little bit. Let me make them a little bit palatable. Right, so what's the color of the bottom? I think it's like something like 80, right? And this one is, let's say, is going to be 30, 30, 30, something like that, right? So let's actually refresh, and that was not enough apparently. So what if I, okay, so what you don't like? Oh, okay. What's the 80 by FF? Let's like, yeah, I'm doing, so 24, okay. New RGB, though this one is, yeah, it's in terms of from 0 to 1, so we have to do this stupid 094, 094, 0094, and this is just 1. Right, and this one is going to be what? So what is it called? So it was 30, so it's going to be 18, yeah. 18, okay. So that's much better. So yeah, I don't want to keep it you know, red and blue because it's too harsh, right? I just want to keep it like that. All right, so until we actually make it faster. So with the colors it works fast, as you can see. With colors it works fast. As soon as you introduce texture, it becomes slower, right? So until I make this entire thing faster, I don't think it makes sense to keep textures. Anyways, now, so here we're doing wood stuff. Let me get rid of the wood. Maybe I'm gonna get rid of the scene completely here. I mean the floor, yeah, that's what I was trying to say. So no floor in here, and where is the wooden here. Okay, so everything seems to be compiling. All right, everything seems to be compiling. So floor cannot be, what was the line? 97, 97, yeah. Is everything okay? 95. All right, everything seems to be okay. So there was some if false. I think I removed the if false part. So this is that. This is that. Yeah, I just renamed it for whatever reason. Okay. Cool. Implement rudimentary floor rendering. Okay, so it took me 3 days to do that. Right. And I still do not fully understand how I did that exactly, right? I still don't understand that part of near clipping plane, like dividing by near clipping plane. But I'm glad that I have at least something working, so that means we can actually start iterating from here. I mean, to be fair, 3 more days for ceiling, let's go. Ceiling is basically that, you just like put it upside down, right? So it's literally the same thing. So it shouldn't be that hard. Famous last words, right? So shouldn't be that hard. So, but I mean, whatever. Yeah, I can try to do that. It should be literally the same thing, honestly. I mean, why is it not just rendering floor? Just take the same shit and call it rendering ceiling and just iterate it differently. Okay, so ceiling. Right, so now we're iterating from half up until that, but now we're iterating from 0 up until half of that. So that's what we're doing now, aren't we? I'm pretty sure that's what we're doing now. And essentially, instead of get floor, let's get ceiling. Get ceiling. Okay. Oh, I mean, it's not available. Get floor. Okay, so ceiling. Okay, so we can actually call this, you know, query place color floor 1. It said floor 1, motherfucker. Oh, no, sorry. I'm a little bit tired already. And this one is going to be essentially color 2, color 2. All right, so floor 2. And let's introduce like a ceiling colors, silly colors. Ceiling colors. So this one is going to be ceiling RGBA red. Let's actually make it bright. Ceiling 1, so we can actually instantly silver that. RGBA blue. There we go. So that's what we have. Yeah, a ceiling 2. Okay. So in here, instead of floor, we're doing ceiling. So get ceiling, get ceiling. All right. So yeah. Why is it not that? Okay, so this kind of stuff, like differences could, okay, I see why this could be a problem. I see why this could be a problem. But not that much, honestly. You just do, okay, so let's give it a try and see how it fails. Render floor and render ceiling. Okay, let's go. Something crashed apparently. Render ceiling is not defined. Really? Oh, okay, I see. So I think, yeah, I think it's not going to just work. And it just worked. That's a very sus sky. But I mean, it's just like moving in a different direction. Yeah, that's understandable. So we can actually disable floor, right? So, and maybe even, it actually looks kind of cool, honestly. It kind of looks cool. So I'm moving, yeah, so if we enable both of them, if we enable both of them. Yeah, they're moving in the opposite direction. Walls, I need the walls. Damn, that actually kind of looks cool. I really like that. Okay, another 3 days to implement the floor. Yes, I agree with that. Another 3 days to implement the floor. So what if we I don't fucking know, just invert the whole thing. Right. So if I just do render ceiling, so just do that, but let's just invert the coordinates. So this is that. So this is y. So here is this SZ. First try. First try, motherfucker, first try. First try. Haters gonna hate. Haters gonna hate. Yeah, bro. That was easier than expected. It's literally floor, but you just like inverted. So it's literally floor, but you just inverted. Okay, so now we have a ceiling. So now we can even like do things, like we can have scenes like inside of the dungeon or something, which is kind of cool. Right, I really like that. All right, so implement rudimentary ceiling rendering. Okay. Yes. That's pretty cool. So maybe eventually this thing will turn into like a web game, and that's kind of my goal, right? So I wanted to make a game out of this entire thing. Right, so, and we already have like a rudimentary engine. I would really like to improve its performance, because right now performance is shit. Right now the performance is shit. Okay, so what's gonna be the next plans? I think I'm gonna take the past 3 days and I'm gonna try to edit them a little bit and concatenate into a single episode that I'm gonna upload it to YouTube. It's gonna be a huge episode, but I kind of want to tell the whole story, because I think the story of figuring out how to render floor and ceiling is kind of interesting, even though it's kind of long. Because if you go through all of these 3 days, there was a lot of interesting things here, right? So we tried different hypotheses and stuff like that. So I think it's worth like preserving the entire story of this, of implementing this feature. What's funny is that like I don't even fully understand this implementation. Again, I still don't understand division by near clipping plane. This is something that I'll have to sit down and figure out by my own, right? So maybe in the next episode I'm gonna explain how to do that. But your CPU will always be hot while you play this game. My CPU is always hot even if I'm not playing this game. That's the thing. So I close this game and my CPU is still at 100%. This is because I'm also streaming. So I have a very old laptop, right, from which I'm also streaming, and I'm doing this kind of stuff. Actually, the game, when I'm not streaming, works way faster. Like magnitudes actually faster. So whatever the performance I have in here is not even representable of the game. So yeah, so which is kind of useful for developing like you know, high performance applications, right? Because you're kind of forced to write them, you know, fast. So, and after we rewrite this entire thing in C, I think it's going to be even faster, right? So my plan is to actually just like take the Olive C approach. Let's take a look at it. This one. So here is the 3D, but this is the 3D that we render pixel by pixel in WebAssembly. So, and also this stuff. So you can actually find it in here. It's not WebGL or anything, and it's when I'm also streaming, right? So I'm super proud of this this thing actually. I'm super proud of these things. And I'm pretty sure we can actually rewrite that engine in a similar style. Right, but that's going to be already the next episode. All right, that's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on the next recreational programming session with Ahu Mr. Azozin. Love you. Mwah. All right, this is the footnote of the session, and I think I figured out why we have to divide the whole thing by nearest clipping plane. So let's take a look at the way we render the walls. To render the walls, we have a pretty interesting method of player, which is called FOV range, which returns you 2 points, P1 and P2, as you can see. So what those points mean? Okay, let's this thing be a position of the player, P. So on top of the position, player also has the direction where it's looking currently, right? So, and how we calculate P1 and P2. P1 and P2 are essentially the wings of FOV cone, right? Field of view cone. So we basically move this vector forward towards the distance of nearest clipping plane, right? So you can kind of say that this is NPC, nearest clipping plane. So, and then we render this nearest clipping plane and we extend these two things in here. And this one is P1 and this one is P2. Pretty simple, right? And then we interpolate from P1 to P2 and we're basically shooting rays and just sitting where they're and just seeing where they hit, and if they hit something, we render the pixels accordingly and stuff like that. So to render floor, we actually have to look at the entire FOV cone from the side. So let's quickly do that. So here is P. Right, so NP is at the level of the height of the player and stuff like that. And here's the projection plane, also known as nearest clipping plane. We're using these two terms interchangeably, it doesn't really matter. So essentially, let's imagine that we want to render this specific pixel. To render this specific pixel, what we have to do, we have to shoot a ray from the position of the player, from the position of the eyes of the player, through that pixel towards the floor and see where it hits the floor. And as soon as it hits the floor, we know the coordinates of the tile, from which we can figure out the color of the pixel and so on and so forth. Right, so let's actually denote the sides of this sort of triangle that we have on here. So A, B, and hypotenuse is the C. So we know A, right, because that's the height of the player, that's pretty simple. And we need to know B, but we don't really know it. So, but what we can know, we can actually know a smaller b, which is like a distance from the player towards the screen. And let's call it something like b prime. And we can also know sort of like a smaller version of a, which is a prime. So by dividing b by a prime, we kind of find the tangent of this alpha, which enables us to scale this smaller triangle to a bigger one by multiplying by full A. Right, so this sort of like a fraction allows us to scale this smaller triangle to a bigger one. And that's how we find the full B, and that's how we find where to look for the pixels and stuff like that. So B prime is essentially the distance from P to P1, nothing particularly special. So there's something interesting about how we compute FOV cone when we're looking top down. So the angle of FOV does not care about this specific distance. So essentially, if we put the projection plane a little bit further, this angle will stay the same because we just extend these wings of FOV cone, and now this is P1 and P2. So nothing really changed. But if you put the clipping plane further while looking from the side, while rendering the floor, look what is going to happen. Let's imagine that now the clipping plane is a little bit further. And so the pixel that we're trying to render is actually located in here. So if you shoot a ray from that pixel, you're looking at a completely different pixel on the floor. And in fact, you are working with a completely different small rectangle. So, and look at that. You extended the size of B prime, but the size of A prime stayed the same. So to accommodate for the change of B prime, you also need to change A prime, or essentially multiplied by the same amount B prime is extended, which is nearest clipping plane. Nearest clipping plane, NCP. I call it NPC, so it's supposed to be NCP. brain damage from the memes, I'm sorry. So, and essentially what we were doing, we're not dividing by NCP. We were extending the size of A prime proportionally to the change of the size of B prime. That's what we were doing. So I think that's how it works essentially. Like at the time I was working out the math, it was not obvious to me. But once I tried to implement that, I figured out, right? So fuck around and you'll find out. So yeah, I hope this entire 3-day session was interesting. So I don't know for how many people this kind of stuff is interesting, but if you watched until this point, thank you for being interested in this kind of nerdy shit. So yeah, I really appreciate you. So yeah, thanks everyone for watching, and I see you on the next recreational programming session with Mr. Azuzin. I love you. Mwah.